If a military clash erupts in the Indo-Pacific, the US Navy's top question will be, how do you sink a Chinese aircraft carrier fast? The answer might just be more surprising and terrifying than anyone expected. At this year's RIMPAC exercise, the US Air Force unveiled a game-changing capability that left China's military brass sweating. A cheap, devastating weapon dropped from the most advanced bomber ever built. A massive 39,000-ton ship was sent to the bottom of the ocean in minutes, thanks to a bomb so smart it doesn't even need human guidance. This is Quick Sink, and it's set to rewrite the rules of naval warfare. But how did the US develop this stealthy ship killer? And why does it strike fear into the hearts of China's naval commanders? Stay tuned as we dive into the cutting-edge tech and tactics that could change the future of the Indo-Pacific. As tensions in the Indo-Pacific rise, the stakes are higher than ever. The question of how to neutralize a powerful enemy carrier is more crucial now than at any point since World War II. Even during the Cold War, the United States and its allies understood that any conventional confrontation with the Soviet Union would be decided on the battlefields of Europe and in the skies over them. In contrast, any conventional confrontation with China will be decided in the seas and skies of the first island chain. China understands this too, which is why it shifted much of its military resources away from its tradition of being a strong land power and into a bid to become a sea power. For a China that depends on maritime trade coming through the hostile choke points of the first island chain, there is no other option. As a result, China expanded its navy. It now has 3 aircraft carriers with a 4th on the way, aiming to increase its fleet to 5 carriers by 2030 and 6 by 2035. Each carrier has shown advancements like the Fujian's catapult propulsion system. However, these developments are not without challenges. China's rapid expansion lacks the battle-tested experience and logistical support that the US Navy has honed over decades. While the Type 004, China's first nuclear-powered vessel, promises longer missions, it still faces significant hurdles in matching the operational capabilities and global reach of the US carrier strike groups. The United States Navy has 11 aircraft carriers in service, but it cannot commit all of these to the Indo-Pacific region. Other hotspots like the Middle East and Eastern Europe also require America's attention. This reality is one of the things Beijing is counting on. China hopes that in the 2030s it will achieve local naval superiority against the divided US Navy. But dreaming and doing are two very different things, especially when you're up against the world's most battle-hardened and technologically advanced fleet. America's military brass understands this threat, and so is looking to find force multipliers, ways to inflict disproportionate harm to an adversarial China with fewer resources, and we saw a couple of these flowers begin to bloom in the summer. RIMPAC, Rim of Pacific, is the world's largest naval military exercise. It occurs every 2 years, usually in June or July. The 2024 exercise involved participants from 29 countries. This year's RIMPAC was notable in more ways than one. The United States used it to reveal the AIM-174B, its air-launched version of the RIM-174. The incorporation of this ship-based missile onto an air platform now gives the United States comparable reach to China's PL-15 and PL-21 missiles. However, these missiles are versatile and can hit targets in the skies, on land, and on sea. Thanks to their air-launched attributes, these missiles can potentially threaten important Chinese military assets in its home territory, key Chinese ships, and make any invasion of Taiwan even more difficult and costly. In most years, the revelation of these missiles, once thought to be exclusive to ships, may have been the most notable talking point from RIMPAC. But the US military has another trick up its sleeve, one even bigger than the last. The Air Force was not about to let the Navy steal the spotlight. One of the stars of the Air Force's show was the USS Tarawa, on loan from the Navy. This ship was 820 feet in length and weighed 38,900 tons. The Tarawa was built in the early 1970s and decommissioned in 2009. Named after the Battle of Tarawa in World War II, it was an amphibious assault ship. The US Navy gives the following mission description to amphibious assault ships. They must be able to sail in harm's way and provide a rapid buildup of combat power ashore in the face of opposition. This means amphibious assault ships have to carry a lot of stuff, including aircraft. These ships can do vertical short takeoff and landing (VSTOL), short takeoff vertical landing (STOVL), vertical takeoff and landing (VTOL), tilt rotor and rotary wing (RW) aircraft operations. In addition to helicopters, these ships are capable of hosting F-35B aircraft, which are designed for short takeoff and vertical landing. Unsurprisingly, the US Navy's official fact file on amphibious assault ships said that they resemble small aircraft carriers. The Tarawa was in fact only slightly smaller than France's Charles de Gaulle aircraft carrier. So if you need to practice operations against an aircraft carrier, a decommissioned amphibious assault ship like the Tarawa is a pretty good bet, which is why we've referred to this ship in the past tense, because it is no more. It lies as a wreck beneath the waves. The once gallant ship became a giant floating punching bag for the US and its allies participating in RIMPAC, but punching bags are useful for training in preparation for a fight, and the Tarawa was no exception. The Tarawa was hit with several weapons. One of these included an AGM-158C LRASM launched by an FA-18 Super Hornet. This weapon is a stealthy subsonic cruise missile with a range of over 200 miles and packs a 1,000-pound warhead. The missile is also a smart weapon, able to navigate autonomously in response to enemy radar and defenses through artificial intelligence that does not require human or even satellite guidance. The missile hit and did heavy damage, but it was not enough to sink the ship. After the LRASM impact, an Australian destroyer, the HMAS Sydney, got in on the fun. The Sydney used a naval strike missile. This is a projectile developed by the Norwegian Kongsberg Defence and Aerospace Company, the same firm behind the NASAMS missile defense system. It has a range of at least 115 miles and carries an 880-pound high-explosive warhead. The test was an important one for the Australian Navy. Vice Admiral Mark Hammond, the Australian Chief of Navy, hailed it as a demonstration of his country's ability to hold a potential adversary at a long range and deter any hostile projection of power against Australia. Everybody understood who that was referring to. The missile hit the Tarawa and did more damage, but the large ship stayed afloat after this impact also. But these two were just the opening acts for the main event. A B-2 Spirit, armed with a bomb called the Quicksink, now flew into action. The Air Force started the Quicksink program in 2021, when it toyed with the concept of using standard JDAM bombs to hit a specific point on an enemy ship, including at the top, the waterline, or just below the waterline. The Air Force wanted to develop this Quicksink capability out of recognition of this new threat environment that the United States and its allies faced. With the increasing Chinese naval threat in the First Island chain, it realized that it needed to get much more involved in the anti-ship business than it had been in the past. The Quicksink program was designed to allow the Air Force to modify not only existing weapons for anti-ship purposes, but future weapons as well. One modification to the typical JDAM was a redesigned nose plug. The new plug prevents a JDAM bomb from bouncing in an unexpected direction if it hits the water. The concept was first put to the test in 2022. This test involved the use of a GPS-guided GBU-31 bomb launched from an F-15E Strike Eagle to hit a cargo vessel. The bomb penetrated the target and split it in two, causing it to sink rapidly. Air Force officials have been high on the Quicksink, saying that it's a more effective way to sink ships than heavy torpedoes. Being air-launched, the Quicksink provides more flexibility than a torpedo, potentially at a longer range. The RIMPAC test involved a Quicksink kit attached to a 2,000-pound Mark 84 bomb. The kit includes GPS-guided tail fins, which steer the munition to its target once dropped from the air. Quicksink kits also involve new radar seekers installed on the nose of the munition to help it identify and move toward the target. The Quicksink kit also comes with an infrared imaging seeker mounted to the side of the bomb. This seeker helps the bomb to identify its target ship and guides the bomb towards the target's vulnerable hull just below the waterline. The bomb detonates there, producing a similar effect to a heavy torpedo launched from a submarine. This was the Tarawa's fate in the RIMPAC exercise. The B-2 Spirit took off with the converted Mark 84 and sunk the Tarawa in this one shot. The message was clear. The United States had demonstrated its ability to sink very large ships very quickly through the platform of a bomber that would be difficult to detect beforehand. There are only 19 B-2 bombers in the USAF's fleet, but the B-21 Raider will have the same capability once it makes its debut in the 2030s, and there will be a lot of them. The Air Force has suggested that a fleet of around 200 B-21s will be needed to deter and defeat any foe. A force of hundreds of B-21s armed with Quicksink bombs poses a significant danger to China's naval plans. Another attractive part of the Quicksink munition is in how low the cost is. The B-2 Spirit might be the most expensive aircraft ever to take to the sky, but the mission it carried out at RIMPAC can be done on the cheap. Anti-ship missiles are very expensive. For example, a single LRASM currently costs $3.24 million. The naval strike missile that also hit the Tarawa had a unit cost of nearly $2.2 million in 2021. Other anti-ship missiles like the Block 2 Harpoon can cost over $2.25 million per unit. The RIM-174, now also the AIM-174B in its air-launched configuration, can cost nearly $5 million apiece. Torpedoes are also expensive. The most powerful weapon to sink large nuclear submarines and surface ships in the US military's arsenal has been the Mark 48 torpedo. This torpedo is designed to detonate underneath surface ships and break apart their hulls, causing them to take in water fast, much like the Quicksink. However, these torpedoes are even more expensive than anti-ship missiles. The latest version of the Mark 48, called the Mod 7, has a unit cost of $4.2 million in the Navy's budget for the 2025 fiscal year. With such expense, fewer of these units are produced. Only about 50 per year were made in 2017, the year after the Mod 7 was introduced. The war in Ukraine has revealed how high the depletion rate is in a war against a peer or near-peer adversary, even with weapons significantly cheaper and easier to manufacture than these anti-ship missiles and torpedoes. Ukraine's hunger for 155mm artillery shells might be the best example. Having cheap and abundant weapons on hand to deal damage to more costly systems has proven essential for an effective fighting force. This is why Ukraine's drone pilots have been such a boon for its war effort. These drones can be made quickly and destroy tanks worth millions of dollars on the cheap. The Air Force intends the Quicksink to carry out the same type of mission against even more expensive targets. Ship-killing torpedoes also have limited flexibility. The Mark 48 can only be delivered via submarine, and while the United States has the world's premier submarine force, those vessels might not be conveniently nearby to respond to an emergency. They also need to get into range that could potentially be dangerous to deliver their payloads. But the Quicksink helps to get around all of these limitations. First, it takes a cheap weapon and turns it into a smart killer. For example, the United States introduced the Mark 84 bomb in the 1950s. It has a large surplus of these that have been in storage for decades. New ones are easy to produce too, with a unit cost of $16,000 in 2021. Adjusting for inflation, the price will be about $13,500 2024 dollars. The addition of a JDAM kit would cost an additional $25,000. There are a lot of these JDAM kits lying around too. Boeing has made at least 500,000 of them since 1988. Now RIMPAC has proven that these cheap weapons can destroy large ships that can cost billions, all while delivered from a stealth bomber over a dozen miles away, long enough of a range for it to avoid most dangers. The delivery platform can also respond to a mission at any time, providing more flexibility. The operation against the Tarawa was not the only successful test of the Quicksink at RIMPAC 2024. The USS Dubuque was also a target. This ship was commissioned in 1967 as an Austin-class amphibious transport dock. These types of ships are designed to support landing operations by carrying troops and equipment to hotspots. The Dubuque displaced 9,201 tons while light and weighed nearly 17,000 tons at full displacement. Though much smaller than the Tarawa, the long decommissioned ship was also sunk at RIMPAC with a B-2 delivered JDAM bomb, proving that the bomb can hit a variety of targets. The Air Force Research Laboratory, the organization behind the Quicksink, described what it would add to America's defense posture. Quicksink is an answer to the need to quickly neutralize menacing maritime threats over vast areas around the world. Everybody knew who the message was meant for. Things get worse for China if it has ideas to get more aggressive. The B-2 Spirit can hold far more than one Quicksink. It can carry 16 Mark 84 JDAM bombs in total, so it has shots to spare. If ever deployed, more than one enemy ship could come under the B-2's sights. A B-2 operating from Andersen Air Force Base in Guam is now capable of responding to this mission on short notice. With a vaster fleet of B-21s coming in the 2030s, this capability will increase. The Air Force's Quicksink plans don't stop at bombers either. The service also wants to create anti-ship tools capable of being launched from fighter aircraft like the F-35A and presumably the NGAD. Although these fighters would likely not be able to carry bombs big enough to sink carriers in one shot while maintaining their stealth profiles, they will still pose a danger to other important ships. They would also significantly increase the flexibility for delivery of Quicksink bombs. Aside from the small number of aircraft, one of the limitations involving B-2 delivery for Quicksink is that there are only a few locations capable of hosting the Spirit. These bombers require specialized, climate-controlled hangars to maintain their stealth coating. Nearby bases capable of hosting the B-2 include the aforementioned Guam and the facilities at Diego Garcia, but it could still take hours for the Spirit to get to a hotspot from these locations. Most B-2 bombers are concentrated in Whiteman Air Force Base in Missouri, thousands of miles away from a potential flashpoint. The B-21 may be more robust as stealth technology has advanced since the B-2 was cutting edge, and the Air Force plans for there to be enough of them around the world to respond to an emergency, but the addition of Quicksink capabilities with faster fighter aircraft that can be stationed anywhere would make the new tool even more formidable and is likely a high priority. Adding Quicksink bombs to fighters stationed in Japan or the Philippines would be a significant obstacle for China to overcome if it intended to threaten Taiwan. The Air Force is also experimenting with adding even longer range to its Quicksink ability. In 2023, Boeing announced its intention to turn JDAM bombs into cruise missiles. This transformation would come through the Powered Joint Direct Attack Munition (PJDAM) concept. The company completed wind tunnel testing of the PJDAM that August and started to create digital models of the munition that would support further development. The PJDAM would have 4 parts: a jet engine, a pair of pop-out wings, the GPS-guided inertial navigation system found on a typical JDAM, and the standard low-drag bomb as the warhead. A typical wingless JDAM might have a 15-mile range. An extended-range JDAM with pop-out wings might have a 45-mile range. The PJDAM would be able to hit targets 300 miles away. The 2023 PJDAM tests involved 500-pound bombs. These smaller munitions can be carried on fighter aircraft, including in the internal weapons bays of the F-22 Raptor and F-35 Lightning II, and the NGAD and F/A-XX in the future. These weapons would pose a significant threat to smaller ships, but likely not an aircraft carrier. It's not yet known if there are plans to scale the PJDAM concept up to the 2,000-pound Mark 84 to threaten larger vessels, as seen at RIMPAC. For one, the engine would need to be made larger, likely making it less than ideal to be carried on a stealth fighter. Still, with anti-ship weapons now being a high priority for the Air Force, it would not be surprising if the larger PJDAM becomes a project in the near future. It would be an ideal weapon to fit on the B-21 fleet. The PJDAM would also be comparatively cheap. Although the total price tag would likely run into 6 figures per unit thanks to the addition of a jet engine, the final per-unit price tag would still be much cheaper than a typical cruise or anti-ship missile or the Mark 48 torpedo. Against a large navy like China's, that could come in handy. Between the AIM-174B and the B-2 delivered Quicksync, RIMPAC 2024 revealed that the US military was thinking about how to use old weapons for new purposes. The AIM-174B was once thought to be a ship-based missile only, but now it can be launched from an aircraft, extending its range and potential to disrupt China's so-called kill chain, the web of systems and technologies required for a munition to deliver force to a target. Similarly, the JDAM bomb, once a linchpin of air support for ground forces, has now proven itself a potent anti-ship weapon, capable of rapidly sinking large vessels. Now, when contemplating their plans for Taiwan, China's military brass will have no choice but to wonder whether one of their aircraft carriers or other large ships required to support the invasion will be suddenly sunk by way of a bomber that they could not even see coming. But what do you think about the Quicksync delivered by way of stealth bomber? How will it influence the tense politics of the Indo-Pacific region? Submarines are terrifying. They can travel through deep waters, undetected by ships on the surface, meaning they're ideal for subterfuge and launching unexpected attacks on opponents. More recently, they've taken on a nuclear slant, with countries like the US, Russia, and China designing subs that are capable of firing submarine-launched ballistic missiles, or SLBMs, carrying nuclear warheads. Yet, submarines are not without their disadvantages. But what if we told you that the US has been developing a submarine that eliminates almost all of them? A submarine that's so easy to build and deploy that the maintenance problem is mitigated massively. A vessel that is completely unmanned and entirely autonomous, meaning the human risk of operating submarines is taken out of the equation. And perhaps most importantly, a submarine that moves so quietly through the water that modern equipment isn't capable of tracking it. A submarine sounds like a sci-fi creation. It isn't. It's a reality, and it's named the Manta-Ray, the latest US military innovation that terrifies China and threatens to end Beijing's efforts to build its influence in the Indo-Pacific. So what is the Manta-Ray? In June 2021, the War Zone provided some details, starting with dubbing it a submarine that looks like a docked Star Wars ship. Using satellite imagery to back up its claims, it says the Manta-Ray is a submersible drone being developed as part of a Defense Advanced Research Projects Agency, or DARPA, project, with the submarine intended to be able to complete a host of naval missions. The submarine the War Zone examined is based in Naval Base Ventura County, a Californian base that focuses primarily on the research, development, and testing of new weaponry. It's estimated that the underwater drone's wingspan is around 45 feet, with its overall length being 33 feet. Again, the Star Wars reference comes into play, as the images we've seen so far make the submarine look more like a futuristic plane than a submersible vessel. This size places it somewhere in the middle of the spectrum of unmanned underwater vehicles, or UUVs, the US military has in development. The Manta-Ray is shorter than Boeing's Echo Voyager, for instance, which measures 51 feet long but is also much thinner. However, it's larger than the Remus 600, which is 10.6 feet long and barely over a foot in diameter. However, these dimensional specifications are estimates. Neither DARPA nor the Manta-Ray's manufacturers, Northrop Grumman, have released official figures for the submarine's size. That suggests that development is ongoing, meaning the estimates the Warzone reports may change once the submarine enters service. Speaking of Northrop Grumman, the company provides more details about what the Manta-Ray can do on its website. It describes the UUV as a new class of submersible, with its design being directly inspired by the winged fish that lends the sub its name. The Manta-Ray is designed to conduct long-range and long-duration missions, with a focus on ocean environments that humans are unable to explore in traditional submarines. Better yet, for the US Navy, the Manta-Ray is capable of conducting payload missions, meaning it can not only reach places that regular subs can't reach, but can also carry munitions, such as bombs and missiles, to attack targets. The Manta-Ray is also a modular vessel. At least that's the indication received from how Northrop Grumman shipped the submarine from its manufacturing site in Maryland to Naval Base Ventura County. Naval Technology reports that the UUV was shipped piecemeal, meaning it was broken down into sections that allowed it to be easily transported via road to its destination. Once it arrived, the Manta-Ray was quickly reassembled, ready for testing. A clear advantage over traditional submarines emerges. A regular sub can't be transported so easily. With the Manta-Ray, the US is getting a vessel that it could disassemble, transport to anywhere in the world via on-road vehicle, plane or ship, and then reassemble so it's ready to deploy. Furthermore, this piecemeal approach suggests that Northrop Grumman will be able to easily manufacture the vessel, as well as create replacement parts for existing Manta-Rays. Damage to one of a Manta-Ray's wings, for instance, may not mean the entire vessel has to go in for repairs. Instead, the broken wing can be switched for a new one, with the UUV getting back underwater again far faster than even a slightly damaged submarine will be able to do so. All very impressive so far. However, the two real difference makers for the Manta-Ray come from how it's powered and how it navigates. Starting with powering the vessel, DARPA's chief engineer for the Manta-Ray program, Brian Theobald, developed a novel idea. A 13-year veteran of Northrop Grumman's previous UUV projects, Theobald began working with a renewable energy technology company named Seatrek to come up with a way to harness and harvest the ocean's inherent energy to keep the Manta-Ray running. This partnership led to Seatrek creating a set of energy harvesting products that make use of an ocean's thermal gradient to generate the electricity needed to operate a vessel. This gradient is the difference in temperature between an ocean's surface and the waters below, with the surface waters typically being the warmer of the two. Thanks to Seatrek, the Manta-Ray is now equipped with technology that essentially allows it to keep itself charged with the electrical energy it needs to run without ever having to surface. In short, the Manta-Ray is capable of staying out at sea almost indefinitely, constantly delivering mission data as it does without needing to return to port. Instead, it can travel to various electricity storage locations to recharge. Plus, the fact that it doesn't need to resurface and can actually sink as low as the ocean bed makes it incredibly difficult for another country to track the UUV once it's at sea. Creating these capabilities didn't come without challenges. For one, Theobald's team needed to figure out a way to transfer the new energy its new system stored to the various rechargeable autonomous systems built into the Manta-Ray. That required a new invention, Niobicon. This self-insulating electrical connector tech is the brainchild of Jim Windgasson and Harvey Hack, who are both Northrop Grumman employees. Together they created a connector that's capable of being mated and demated even when exposed to water, eliminating the need for oils and rubber seals to prevent water from impacting an electrical connection. The connector's success all comes down to an element named niobium, which transforms into an ultra-thin and passive film the moment that it makes contact with water. As Windgasson explains, the film prevents current from leaking from the contact into the water. When the connector's two halves are mated, the insulating film is scraped off, allowing current to flow unimpeded through the connector. Once the current is no longer flowing, the film reforms upon contact with the water, and the Manta-Ray is recharged and ready to go. So how does the recharging station work? Dubbed the Mission Unlimited UUV Station, the device is currently in its conceptual stage and is yet to be developed. But according to Theobald, it'll be deployable from a ship, after which it sinks to the bottom of the ocean and anchors itself. The station will then release a thermal energy harvesting pod, which is propelled up, generating and storing electricity thanks to the thermal gradient method mentioned earlier. After a few days, the pod will have gathered enough energy to fully recharge a Manta-Ray UUV, after which it heads back down to the charging station to be stored until the submarine needs it. Assuming the station is successfully developed, it's likely that the US will deploy dozens of them in the oceans around the world. In doing so, it'll create a network of charging stations that enable the Manta-Ray to stay underwater indefinitely. Better yet, the UUV will be taking advantage of an energy resource that's never going to run out. That's according to Kelly Rule, who is a mechanical engineer working with Sandia National Laboratories. Rule, who also serves as an advisor on the Manta-Ray project, says, "One of the things that's really interesting about ocean resources is that they're persistent. In other words, the waters never run out and the waves never stop. According to Rule, this persistence not only means the ocean itself is an unlimited energy resource for the Manta-Ray, but there is also potential for the production of power at a wider scale, especially if a device is developed to capture and transfer the power of ocean currents. Those are ideas for the future. For now, the US has a submarine in development that can theoretically operate underwater perpetually. Still, the energy issue wasn't the only challenge that Northrop Grumman's engineers faced. The communication of information was another. How do you transmit data from a vessel that's always underwater and has no humans on board to an appropriate source? Again, the insulated connectors built into the thermal energy pods the Manta-Ray will use to recharge itself come into play. Those connectors not only transfer electrical current, but can also be used to transfer data from the Manta-Ray to command bases on the shore. How? A clever technology that Northrop Grumman calls data bubbles. Theobald explained these devices. Data bubbles are tiny electronic devices that store data. When released from the station, they float to the surface and begin using their RF satellite communications antenna to transmit data to shore, to satellite, or to a ship. It's an ingenious solution to a communications problem inherent in having an almost permanently underwater vessel. The Manta-Ray itself never needs to surface, meaning it can't expose itself to enemy surface vessels to send data to its operators. Instead, the transmission of data is handled automatically whenever the UUV docks at a charging station, with the tiny data bubbles being capable of sending any information the UUV gathers with no chance of it being spotted by an enemy. How does this differ from the way traditional submarines communicate? Sandbox provides the answers. It points out that most above-surface military platforms, including ships, planes, and vehicles, communicate via radio. That's fine when you're above water. Radio waves can travel freely through the air. But a problem arises for submarines because radio waves get lost in conductive salt water, such as that which makes up the world's oceans. To compensate for this, American submarines currently use very low frequency, or VLF, transmissions to communicate information back to their bases. These transmissions rely on the creation of enormous antenna complexes, which the US has built in 5 places around the globe. Those installations are vulnerable. If the US found itself at war with a country that's capable of firing missiles at these antenna complexes, such as China, it could find itself quickly losing the ability to communicate with its submarines using VLW. It has contingencies in place for if that happens, claims Sandbox. For instance, the Take, Charge and Move Out, or TACOMA, aircraft are tasked with flying out to a submarine's location so they can deploy 5-mile-long antennas while flying in overlapping circles to receive messages. But that only creates more problems. Planes and antennas then become targets, in addition to giving away the general position of the submarine with which they're trying to communicate. The Manta-Ray's data bubbles solve these problems. While it's still possible that the Manta-Ray will also be equipped with VLW, why not build it in if you have the infrastructure in place to use it? It will no longer be reliant on the technology. An enemy could take out every VLW antenna station and fail to put a dent in the Manta-Ray's ability to transmit information to US command posts. Let's summarize what we know about the Manta-Ray so far. The UUV counteracts many of the disadvantages of modern submarines through the use of a host of systems and sensors that allow it to stay underwater for as long as needed. It can be transported in pieces and assembled at any suitable location, allowing it to be deployed from practically any American military base in the world. Considering the fact that the US has around 750 bases spread across 80 countries, it benefits from a multitude of deployment options that could theoretically allow it to send dozens, if not hundreds of Manta-Rays into the world's oceans. Once deployed, the UUVs can descend to depths no traditional submarine can reach, which is useful for both collecting data on the subs that it encounters, as well as for its novel method of recharging. Speaking of recharging, the innovative charging stations Northrop Grumman is developing not only allow that charging to happen while underwater, but serve as communication points thanks to their data bubbles. In short, the US is developing the next generation of undersea technology with the Manta-Ray. There are still challenges to confront before the UUV can be deployed. For one, much of the technology behind the charging stations is still theoretical, meaning it may take several months or years before it reaches a point where it can be reliably deployed. Northrop Grumman will also need to find a solution for the undersea corrosion issue. Constant exposure to salt water could wear away at the Manta-Ray to the point where it's forced to return to base early for repairs. There's also the pathfinding challenge, as the Manta-Ray is a UUV with no human on board to control its direction. It's likely that Northrop Grumman will implement artificial intelligence here, likely combined with an array of sensors that allow the Manta-Ray to identify its surroundings so it doesn't crash. These are all challenges that Northrop Grumman and DARPA will confront during the testing phase, a phase that is already well underway. In May 2024, DARPA announced that a Manta-Ray prototype had completed a full-scale in-water test around the Southern Californian coast. The tests, which took place between February and March, examined the craft's aerodynamic performance with a focus on submerged operations. Buoyancy, control, and propellers were all tested, allowing DARPA to confirm that the submarine could steer while propelling itself through the water. DARPA's Manta-Ray program manager Dr. Kyle Werner confirmed that the tests went well. Our successful full-scale Manta-Ray testing validates the vehicle's readiness to advance toward real-world operations after being rapidly assembled in the field from modular subsections, said Werner. In other words, the new UUV works, both in terms of its undersea operations and when it comes to being transported piecemeal to a location so it can be assembled and deployed. By now it's clear that the Manta-Ray is an extremely impressive piece of equipment and will only grow more impressive as DARPA and Northrop Grumman get their supporting systems up and running. But there's one country that will be watching these developments because it's terrified of what the emergence of the Manta-Ray could mean: China. As part of its massive military modernization, China has been building submarines at a rapid pace. That's according to a July 2024 Newsweek report, which claims that satellite imagery shows that China is building new diesel-fueled submarines to go along with 48 it already has. Of those 48, 21 are Type 039A/B submarines, also designated as the Yuan class by NATO, which weigh 3,600 tons and are capable of firing missiles at ships. Newsweek claims the Pentagon believes China has ramped up production of these Yuan-class subs to the point where it'll have 25 more of them by the end of 2025, bringing its total diesel-powered submarine stock to 73. That's on top of the 12 nuclear-powered submarines China currently operates. The message here is clear: China is trying to dominate under the waves. It's amassing a fleet of submarines that will give it a stronger presence than both Russia and the US, which currently have 65 and 64 submarines respectively. The problem for them is that the US is now playing chess while China is stuck playing checkers. As China invests more into building traditional submarines to expand its underwater reach, the US is investing in unmanned and revolutionary new submarines that represent the next generation of technological advancement with this type of equipment. As is so often the case, China is playing catch-up to the US. Once the Manta-Ray is ready to deploy, China will be at a clear disadvantage because it will be restricted by the fact that its submarines are massive machines that require consistent maintenance and can only really move from place to place under their own steam. The US won't have those restrictions with the Manta-Ray. Remember, this is a small submarine that can be disassembled and transported to almost any location in the world. That means the US could pack it on a plane if it wished and fly it to a dock from which it could be reassembled and deployed. Why does this matter when it comes to China? Earlier we mentioned that the US has 750 military bases spread around the world. An enormous 120 of those bases are in Japan, with another 73 being in South Korea, both countries with which China is vying for control and influence over the Indo-Pacific. In particular, China is attempting to control the South China Sea, through which around a third of global shipping passes. China believes it owns almost the entirety of that waterway, which is a claim disputed by a host of countries, including the Philippines and Malaysia. The tussling over the South China Sea has led to China taking a submarine-heavy strategy in its waters. This was revealed back in 2016 by the BBC, which noted that China was building up a nuclear submarine force that would use the South China Sea as headquarters of sorts, from which China could break out into the Pacific Ocean as it saw fit. In particular, China has deployed Jin-class submarines into the South China Sea, with each being armed with up to 12 JL-2 nuclear missiles. The intention is clear. Those submarines patrol the depths of the South China Sea, lying in wait just in case they receive the order to attack another country, such as the United States. Key to that strategy's success is subterfuge. The subs need to be able to cross over the Pacific Ocean undetected so they can get within range of the United States. This is where the Manta-Ray presents a serious problem. Before the creation of America's new UUV, Chinese submarines essentially controlled the South China Sea, but more importantly, they were incredibly difficult to detect, leading to the US having no idea where they might be at any given moment. With Manta-Rays deployed from bases in South Korea and Japan, the US now has the ability to send an almost undetectable fleet of UUVs into the South China Sea to keep tabs on what China is doing. Those UUVs never need to surface, assuming the technology is developed to the point Northrop Grumman hopes, and can use charging stations on the ocean bed to send information back to US command. In short, China's traditional submarines won't be able to do a thing about the Manta-Rays gathering and transmitting information about them. Even if a Jin-class sub spots a Manta-Ray in South China Sea waters, the Manta-Ray can descend to depths the Jin-class can't reach. And worst of all for China, if war did break out, the fact that Manta-Rays can be equipped with a payload means the US could use them as kamikaze weapons to take out China's subs. After all, the UUVs are unmanned and, by all reports, appear to be easy to manufacture and assemble now the technological aspects have been confronted. Where does this leave China's submarine strategy? As recently as August 2023, China was running anti-submarine drills in the South China Sea. but those drills showcase how far behind the times China is when compared to the US. Reuters reports that the drills involved China sending out a dozen patrol craft, which were tasked with flying for 40 hours over the South China Sea to search for submarines that might be surfacing. Those planes also simulated attacks on the submarines they spotted. These drills will be useless for dealing with the Manta-Ray. A UUV that never needs to surface can't be spotted by patrol aircraft. Again, the chess versus checkers analogy comes into play. The US is developing a threat to China that upends every measure China has to guard against that threat. While Beijing is trying to figure out how to locate traditional submarines, it'll be completely in the dark when it comes to the ghost fleet of manta-rays that may be coming. Therein lies another problem for China. Detecting manta-rays will be almost impossible using current techniques. The maritime patrol aircraft strategy it was practicing back in August 2023 has existed since the First World War and has proven effective against traditional subs. The aircraft scans a large area of the sea, looking for surfacing subs or even their periscopes. Modern aircraft even have sensors that allow them to detect the heat from vessels that may be submarines. A diesel-powered sub, for instance, generates a distinctive heat signature that can be detected if it's near the surface. That signature doesn't exist in the Manta-Ray, thanks to it being electrically powered. The UUV also doesn't need to surface to use a periscope. There's nobody inside to examine the surroundings anyway, making patrol aircraft pointless in combating America's new submarine. The only thing they could possibly scan for are the thermal energy harvesting pods the charging stations release. Devices so small, they'll be almost impossible to spot. And even if the patrol aircraft spot a pod, they've only found the location of one of what could be dozens, even hundreds of charging stations under the sea. They haven't found a Manta-Ray. Beyond simply looking for periscopes and emerging submarines, patrol planes can also be equipped with magnetic anomaly detectors, or MADs. These magnets are placed in a pod at the rear of the aircraft to isolate the electromagnetic noise the aircraft itself generates. With that isolation complete, the MAD sensors scan the Earth's magnetic field to pick up on sound-based anomalies. This could reveal the presence of a submarine under the water, though only when combined with sonar buoys dropped by the aircraft, which are used to pick up sounds. That won't work against the Manta-Ray either, as the UUV barely generates sound, and certainly not to the level that a diesel-powered submarine would. Where does all of this leave China? It's facing the prospect of a United States that could, in a few years, deploy dozens of Manta-Ray UUVs into the waters it wants to control. These new submarines will be practically undetectable, allowing the US to gather data about Chinese operations and submarines, and could even be used to attack Chinese subs and ships thanks to their ability to carry a payload. Billions of dollars China has invested in traditional submarines could ultimately be rendered moot, as it once again finds itself playing catch-up to a technology that another nation has invented. Still, it's worth pointing out that the Manta-Ray and its many supporting systems are not operational yet, despite the submarine itself having undergone several successful tests. We'd love to hear what you think about this UUV and what it means for China. Could the US use the Manta-Ray to dominate the South China Sea and thwart Chinese plans?
The Indo-Pacific is home to rising tensions, territorial disputes, and a fierce battle for supremacy. In one corner is China, a country seeking to become a global superpower by aggressively expanding its influence across the Indo-Pacific and beyond. With its military buildup, sprawling claims over the South China Sea, and an unwavering ambition to bring Taiwan under its control, it's clear that China wants to rewrite the rules of the game, challenging any who dare stand in its way. But unfortunately for China, the country that's increasingly standing in its way is an actual superpower that no other country can challenge easily: the United States. Now, the US might not have the same geographic advantage, military infrastructure and presence, support and access as China does in the region, but what the US does have is a technological edge and unmatched naval innovation that can project power across vast distances with unparalleled precision and lethality. And at the heart of this innovative arsenal, USS Lewis B. Puller, an extraordinary vessel that could single-handedly decide the naval war between the US and China. And that's why China, with all its might and ambition, is terrified of this ship. But what makes USS Lewis B. Puller such a game-changer in the Indo-Pacific, and which problems was it made to address? Keep watching to find out. Though the US had already had a presence in the Indo-Pacific, World War II marked a pivotal shift in its strategic approach to the region. To continue its major military campaigns against Japan in the Pacific theater, the US built an airstrip on Canton Island, now part of the island of Kiribati, some 1,900 miles south of Hawaii. As a key refueling and staging hub for trans-Pacific flights, the airfield was essential in preventing the Allied nations in the Pacific from being encircled or isolated by enemy forces. But then World War II ended and the US gradually shifted its focus away from the Pacific Islands, redirecting its attention to Europe and other global priorities during the Cold War. This pivot led to a period of strategic neglect in the region, as US foreign policy concentrated on different fronts. Over the decades, this lack of sustained attention created a vacuum that China has been eager to exploit, advancing its influence through investments, political maneuvering, and strategic partnerships. The perfect example of this? The US-built airstrip in Kiribati we just mentioned. Some 8 decades after its construction, China is the one that wants to take control of it and restore it to full functionality. Though the Kiribati government claims that this 6,562-foot airstrip will be solely used for civilian purposes to improve transport links and bolster tourism, its relative proximity to Hawaii makes it a potential asset for military intelligence operations. The situation in Kiribati underscores the broader challenges the US faces in the Indo-Pacific. Its historical influence is being increasingly contested by China's assertive expansion. Should this expansion persist unabated, China could very well undermine regional security and bring the People's Liberation Army closer to US territory than ever. With this in mind, let's discuss the main challenges China poses in the region to understand how USS Louis B. Puller fits into the strategic response. The number one issue the US faces in the Indo-Pacific is China's growing military presence in the Pacific Islands, including Kiribati and the Solomon Islands. Beijing is entering into security pacts with these nations, allowing it to deploy Chinese military personnel and police on their territories. But why does this matter? Well, it's simple. If China's troops and police are present in a strategic location, the US will likely lose its access to it and all the critical infrastructure it houses. Besides swaying nations in the Indo-Pacific to join its side physically, China has also done so diplomatically. You see, Beijing has successfully convinced a number of nations in the region, including Nauru and Solomon Islands, to shift diplomatic recognition from Taiwan to China. The goal? To further isolate Taiwan and undermine the US support for the island. The end goal? To completely erode the US diplomatic standing and stability in the Pacific Islands and bring Taiwan under Chinese control. China is pursuing this goal through economic and infrastructure investments too, trying to strengthen its foothold in the Indo-Pacific. That's why it's launched a number of projects in the region, including Tonga's water supply projects and port infrastructure in Fiji, each of them strategically positioned to secure influence, facilitate military access, and of course, challenge US dominance. With how aggressively China is pursuing its goals in the region and beyond, seeking to reshape the international order, a direct conflict between China and the US can't be ruled out. In fact, the escalating tensions and strategic competition are almost making such a clash inevitable. Now, you might think that China wouldn't stand a chance if this conflict were to erupt. After all, the US boasts unmatched military capabilities, economic strength, and global alliances. How could China possibly compete? Unfortunately, things aren't as simple as that. In the very region where this conflict would take place, the Indo-Pacific, almost everything is working against the US, making the logistics of a potential conflict nothing short of a nightmare. How so? Well, let's see. What do you need for a successful conflict in terms of logistics? First and foremost, you need a network of highly connected military bases. Take the Cold War as an example. The US was anticipating a confrontation with its number one enemy, the Soviet Union, so it established a vast network of highway-connected military bases stretching from Italy to Germany. These bases served as the logistical backbone of the US's military operations in the northern European plains, which were considered the primary theater at the time. But the northern European plains spans an area roughly half the size of the contiguous US, which occupies about 3 million square miles. The Pacific Ocean, on the other hand, covers roughly 60 million square miles. That's almost 1/3 of the Earth's total surface. So even though the US military has bases in the Pacific, this region is so vast that the bases are too far apart from each other and from potential conflict hotspots. Out of the roughly 400 military bases the US controls in the Pacific, the closest to major conflict areas are those located in countries like Japan, South Korea, and the Philippines. Japan alone houses 120 active bases, making it the country with the highest number of US bases in the world, followed by Germany with 119 and South Korea with 73. About 70% of the bases in Japan are in and around Okinawa, a strategically vital region due to its proximity to potential flashpoints like Taiwan and the Korean Peninsula. Though all of these bases occupy approximately 77,000 acres of Japan, it's important to note that not all of them are full-fledged military installations. Some of these bases are nothing but single antenna sites. The second closest military bases to potential flashpoints in the Indo-Pacific are the bases on the US islands like Hawaii and Guam. But their distance from potential conflict areas isn't the only problem. Once the US started recasting the posture of its military forces to address rising threats in the region, Guam was in a severely run-down state. The island's infrastructure, roads, the water supply, the electrical system, piers, the airfield runways, virtually everything was in dire need of repair and modernization. Though the US has since heavily invested in Guam, with infrastructure alone receiving $152 million, the extensive scope of repairs and upgrades means that progress is still slow. Of course, the most advanced and well-equipped US military bases in the Pacific follow the designs of those on the US mainland, such as ones in California and Washington. These bases benefit from state-of-the-art infrastructure, extensive support systems, and direct access to advanced technology and logistics networks. However, while these mainland bases offer superior capabilities and readiness, their distance from the Indo-Pacific theater means they play a more indirect role in immediate regional operations. So basically, there's a Pacific military base's trilemma. The trilemma involves balancing three critical factors: capability, proximity, and infrastructure. Bases in Japan and South Korea are closest to potential conflict zones and can respond rapidly, but they face issues of resource constraints and local opposition. Mainland US bases offer superior infrastructure and technology, but are thousands of miles away from the Indo-Pacific flashpoints of the East China Sea, Korean Peninsula, South China Sea, and Taiwan. Remote bases, such as those in Guam, have strategic importance but struggle with outdated facilities, complicating their effectiveness. From this alone, you can probably understand why the so-called tyranny of distance has been labeled as one of the, if not the, most significant challenges in US military strategy in the Pacific. The maths is simple. The further the military force needs to be projected, the more complex and resource-intensive the operation becomes, especially when distance isn't a challenge for your opponent. But as we previously mentioned, China doesn't only have geography on its side. It also has numerous regional alliances, another logistical prerequisite for warfare, which enhances its strategic positioning while complicating the US's strategic calculus. That's why the US Coast Guard cutter USCGC Oliver Henry was prevented from refueling in the Solomon Islands in August 2022, and why the USCGC Juniper wasn't cleared to dock at Vanuatu port for the same purpose in January 2023. The governments of these countries can label these incidents as bureaucratic mishaps all they want, but the timing and nature of these refusals only confirms one thing: China's influence reaches deep into the Pacific. As a result, even some of the US partners in South and Southeast Asia are avoiding outright aligning with the US against China. Other vital elements of warfare logistics are also on China's side: effective supply chains, numerous command and control centers, complex transportation networks, regular upkeep and repair of military equipment. You name it, China's got it covered. The US, on the other hand, is mostly left to its own devices in the region, even with all the crucial strategic alliances in the Indo-Pacific. After all, the US is usually the one to bear the brunt of all the defense responsibilities within these alliances, so if the US wanted to maintain operational readiness in the region, it had to do it on its own. However, traditional logistics solutions such as sea lift simply aren't viable in this scenario. Not when there's the threat of enemy ballistic missiles, China's expanding influence casting a long shadow in the region, and of course, the tyranny of distance. That's why the US came up with Expeditionary Sea Bases, or ESBs for short. Simply put, ESBs are floating military bases, but don't confuse these with traditional warships designed for combat. ESBs are mobile platforms designed to support a wide range of military operations, with an emphasis on logistics, all while staying out of direct combat zones. These bases will allow the US to project power and sustain operations in contested areas without relying on vulnerable land bases or traditional supply chains. So you've got your aircraft carriers that act like an airbase at sea. There are also amphibious vessels resembling mobile ports. And then you have the ESBs, which can be best compared to a flight-decked garage at sea, a $650 million floating garage. As such, ESB vessels are primarily designed to support low-intensity missions, allowing the US Navy to retask the more high-value surface combatant warships and amphibious warships to more demanding operational missions. But don't confuse low intensity with low importance. While ESBs aren't built for frontline combat, their role is critical in sustaining long-term operations. Supporting missions such as mine clearance, special operations, drone launches, refueling and maintenance, they practically allow high-intensity tasks to take place. As you can probably guess by now, the USS Lewis B. Puller is one of these game-changing vessels. So let's learn everything about it. USS Lewis B. Puller is the first purpose-built ESB vessel to be constructed for the US Navy, as well as the second ship to be named in honor of Lieutenant General Lewis Chesty Puller. Lieutenant General Puller is one of the most decorated Marines in American history, having been awarded 5 Navy Crosses and 1 Distinguished Service Cross during his 37 years of service. He was awarded his 5th Navy Cross for the Battle of Chosin Reservoir in 1950 during the Korean War, with the award citation highlighting his unflagging determination that allowed him to ensure the correct tactical employment of the troops, keep open the main supply routes, supervise prompt evacuation of all casualties, and assure the safety of much valuable equipment which would otherwise have been lost to the enemy. Interestingly, the second US Navy vessel to be named after him, USS Louis B. Puller, shares the legacy of resilience and operational flexibility that Lieutenant General Puller embodied. USS Louis B. Puller was first ordered in February 2012, delivered in June 2015, and commissioned in August 2017 at Khalifa bin Salman Port in Al Hid, Bahrain, becoming the first US-built ship to be commissioned outside the US. Prior to this, the ship's prefix changed from USNS, United States Naval Ship, to USS, United States Ship. The reason for this change lies in the law of armed conflict, which mandates that ships in active combat operations must be designated as USS to reflect their combat-ready status. The ship's hull classification also changed from TESB-3 to ESB-3 to indicate it will be manned by US Navy sailors rather than civilian mariners. Since USS Louis B. Puller was the first purpose-built ESB vessel, it shouldn't be surprising it's also the lead ship in the US Navy's ESB vessel class. This class consists of 5 other vessels: USS Herschel Woody Williams, USS Miguel Keith, USS John L. Canley, USS Robert E. Simonak, USS Hector A. Caffarata Jr. The Canley was last out of the first 3 ships to deploy in February 2024, while the last 2 vessels on the list are still under construction. When the leader among these ships, USS Puller, was being commissioned, the former commander of Naval Forces Central Command, Vice Admiral Kevin M. Donegan, described it as a revolutionary concept. His words were, "The Puller isn't just another ship, but a revolutionary concept, a ship that provides us a key platform that will provide continuity to a variety of operations. So let's see what this platform looks like and which operations it supports." There's no doubt about it, USS Louis B. Puller is unique in every sense of the word. The same goes for its silhouette, which stands out with its distinctive flat-bottomed hull and expansive flight deck, which makes it resemble a floating parking lot. The initial design was based on the hull of the civilian Alaska-class oil tanker, which allowed the US Navy to keep the costs relatively low compared to other fully improvised vessels. For comparison's sake, a San Antonio-class ship, designed for amphibious warfare, costs roughly $2 billion, while an ESB like the Puller can be built for around $650 million. Basically, General Dynamics National Steel and Shipbuilding Company created the Puller by removing the middle section from an off-the-shelf Alaska-class tanker and adding a flight deck. But the spacious flight deck is just one of the Puller's main capabilities. It also has aviation facilities, command and control assets, a mission deck, an ample crew and supplies room. An overview of all these capabilities makes it abundantly clear why China is terrified of this vessel. Let's start with the USS Louis B. Puller's most prominent feature, the massive flight deck. Now, just how massive are we talking? It's approximately the size of a football field, making the Puller's desk the 3rd largest in the US Navy inventory, behind only the actual aircraft carriers and amphibious assault ships, whose decks typically span more than 3 football fields. This deck, which makes up for almost half of the 764-foot-long ship, is large enough to land transport aircraft, such as the MV-22 Osprey, the primary assault support aircraft for the US Marine Corps, and the CH-53 Super Stallion, the Marine Corps' primary heavy-lift helicopter. In total, there's enough room for 4 CH-53s and 2 MH-53s to land simultaneously, which significantly enhances the Puller's operational flexibility and capability in supporting various missions. The former aircraft would use the 4 rotary wing landing spots, while the latter 2 can be accommodated in additional deck space. A variety of other helicopters can also use USS Louis B. Puller's expansive deck, from the smaller Bell AH-1 Cobra single-engine attack helicopter to the larger Boeing CH-47 heavy-lift helicopter. The only aircraft you'll never see on an ESB like the Puller is the F-35B STOVL fighter, as the heat from its exhaust could damage the deck. But helicopters aren't the only military assets you'll find on the Puller. This extraordinary ship also facilitates the launch, operation, and recovery of various unmanned aerial vehicles, or UAVs for short. The Boeing In Situ Scan-Eagle surveillance and reconnaissance aerial vehicle and the Aerosonde UAS drone with multiple mission capability are just some examples. These UAVs extend the Puller's operational reach by providing real-time intelligence and surveillance, as well as supporting reconnaissance missions and enhancing situational awareness. Best of all, thanks to the spacious flight deck, entire swarms of these drones can be launched and recovered simultaneously, transforming the Puller into a mobile command center that can project power and precision across vast expanses of the Indo-Pacific. Speaking of command centers, USS Lewis B. Puller boasts rather impressive command and control capabilities. With over 2 megawatts of surplus energy, up to 40 desks, and plenty of space for information fusion, it can serve as a hub for coordinating complex operations and integrating real-time data from multiple sources. Besides storing and processing massive amounts of data, this ship has the necessary capabilities to keep this data private, which is essential for maintaining operational security and ensuring that sensitive information remains secure from potential adversaries. These capabilities become even more crucial when the adversary in question is China, a country known for its sophisticated cyber capabilities. The next feature of USS Lewis B. Puller that deserves attention is its advanced aviation facilities. Besides the helicopter landing deck we mentioned previously, this ship also features a hangar, which provides ample space for storing and maintaining aircraft. The hangar's design supports a variety of aviation assets, ensuring they are kept in optimal condition and ready for rapid deployment. Given how many times we've used words like massive and spacious to describe this ship, it shouldn't be surprising that USS Lewis B. Puller also offers ample crew and supplies room, the final crucial feature of the ship. As far as the crew goes, this ship can support up to 298 mission-related personnel, including special operations teams. A typical ESB crew consists of 44 military sealift command personnel and 101 military support staff, leaving plenty of space for specialized roles and operational needs. The military crew on this ship operates on a rotational model, with the blue and the gold crew alternating on and off the hull every 5 months. These color designations were originally introduced for the US Navy's fleet of submarines during the Cold War, but are now used across various naval platforms. The goal of this crew rotation system is simple: to allow the ship to always stay deployed and operate in hazardous areas for longer periods. As for the supplies, they can be stored both above and under the deck. The former capabilities allow mission-related equipment to be stored on deck, including up to 4 Mk-105 minesweeping hydrofoil sleds. The latter refers to approximately 82,000 square feet of mission deck space below, including an ordnance storage magazine, underway replenishment facilities, and a spacious area for the installation of containerized mission equipment and handling of rigid hull boats, which can also be launched from the Puller. Here's a quick rundown of a few more facts you should know about the USS Lewis B. Puller before moving on to how this ship performs in action. The maximum speed of the Puller is 15 knots, while its operational range is 9,500 nautical miles. Fully loaded, this ship displaces approximately 90,000 long tons, which provides it with the substantial mass and stability needed for sustained operations in diverse maritime environments. The Puller can even be armed, thanks to 12 stations reserved for mounting 50 caliber machine guns. With all the mind-blowing specs out of the way, let's see how this unique combination of capabilities translates into real-world performance and effectiveness. After being commissioned in August 2017, USS Lewis B. Puller has been part of a number of important operations around the Arabian Sea. At first, this ship was only involved in military exercises: the Alligator Dagger in 2017, the deployment of a detachment from Helicopter Mine Countermeasure Squadron 15 for training in 2018, and deck landing qualifications for US Army AH-64 Apache attack helicopters in 2020. 2022 was when the first notable operational deployment of USS Lewis B. Puller took place. In December of that year, the crew on board the Puller interdicted and boarded the stateless fishing trawler in the Gulf of Oman, seizing 7,000 proximity fuses for rockets, over 4,600 pounds of propellants for launching rocket-propelled grenades, and ammunition rounds, including over 1 million AK-47 rounds. The 50 tons of weapons and ammunition were reportedly being smuggled to the Houthis in Yemen by Iran, but the latter was eventually used as military aid for Ukraine after the seizure. Once the Houthis started attacking commercial shipping vessels in the Red Sea in November 2023, the Puller was deployed to the Arabian Sea to help support maritime operations in the region. In January 2024, the ship served as the launch pad for the Navy SEAL mission that seized Iranian-made ballistic missile and cruise missile components reportedly sent to the Houthi rebels. The Navy SEALs launched from the Puller in a small boat, conducting a mission known as Visit Board Search and Seizure, and that's exactly what they did. They approached it traveling off the coast of Somalia, boarded it, detained its crew, and searched all the holds for weapons and seized them. As of September 2024, USS Lewis B. Puller is still located in the same area, the Persian Gulf, waiting for its next assignment. Let's say that the assignment in question involves standing up to China. How could USS Lewis B. Puller help the US best this rival in the Indo-Pacific? From the very beginning, this ship was designed with the logistics of a conflict in the Pacific Ocean in mind. As Vice Admiral Donegan put it, this expeditionary sea base allows the Navy and Marine Corps team to meet the threats in the region head-on. And since these threats are asymmetric, growing, and ever-evolving, the Puller was also designed to be more diverse and capable than previous warships around the globe. So this ship can be outfitted with support facilities for a range of operations, including special forces missions, counter-piracy operations, maritime security operations, mine clearance, and humanitarian aid and disaster relief missions. Of course, these missions are just extras to the ones the Puller can perform with its native capabilities, such as intelligence, surveillance, reconnaissance, and command and control operations. Thanks to the modular command and control capabilities, the Puller is also a valuable asset for maintaining situational awareness and relaying information. In the context of a conflict with China, virtually all military assets, intelligence, and complex operations across the Indo-Pacific could be successfully coordinated in real time from this vessel alone. USS Louis B. Puller could also be used for medevac and reinforcement, which makes it an essential platform for sustaining operations and ensuring rapid response capabilities. However, due to the tyranny of distance, one role in particular would be a game changer in a conflict between the US and China: the Puller's role as a logistical node. According to some estimates, ESBs like the Puller have the capacity to store over 11 million gallons of cargo, which can be either distributed to troops ashore or used to refuel various sea-based platforms at sea. To understand just how massive this capacity is, all you need to know is that amphibious assault ships like USS America can only carry 1 million gallons of cargo fuel. Even Nimitz-class aircraft carriers, which are basically huge cities at sea, can only carry about 3.5 million gallons of fuel. Technically, this means that a single ESB like the Puller could refuel an entire fleet of aircraft carriers or a large number of destroyers, providing unprecedented logistical support in extended naval operations. But let's say the Puller isn't only carrying cargo fuel. The vast cargo space would allow this ship to transport essential resources to US troops in the Indo-Pacific, preventing China from ever cutting off their supply lines. The best part? These supplies wouldn't just be stored on the Puller. They could also be directly transported to ground troops with one of the many helicopters the Puller can accommodate. This is undoubtedly groundbreaking, as the Pacific Ocean is simply too vast and contains insufficient US-held land infrastructure for any other form of logistics to be effective or resilient. If the troops were to use land ports or airports, China could easily target and bomb these strategic points, disrupting the supply lines. But the same can't be done with helicopters. These aircraft excel at delivering supplies without the need for extensive infrastructure. Spare parts, fuel, ammunition, food, water, whatever US troops needed, the Puller could swiftly deliver via helicopters, ensuring uninterrupted operational capability and reinforcing the US presence across the region. Water is of particular importance, as recent exercises in the Philippines showed that an average Marine uses 20 gallons of water per day for hydration, hygiene, and other essential needs. Thanks to the Puller's onboard desalination systems, the ship could carry enough water to sustain hundreds of troops for extended periods, making it a vital lifeline in remote or contested areas. Essentially, USS Louis B. Puller could resolve virtually all logistical challenges the US would face in a potential war with China in the Indo-Pacific. No nearby military bases? No problem. The Puller can bring critical supplies directly to troops in the field via its extensive helicopter facilities. Forbidden access to ports for refueling? It's all good. The Puller's enormous cargo capacity allows it to refuel sea-based platforms at sea, ensuring that critical naval assets remain operational even if they can't dock at traditional refueling stations. Remote or contested areas? Not an issue. The Puller's ability to operate and deliver supplies from its floating base ensures support even in the most isolated locations. Threats to land infrastructure? Easily circumvented. The Puller's mobility and self-sufficiency mean it can maintain operational continuity while bypassing vulnerable land-based supply routes. Simply put, the Puller is a versatile logistical powerhouse capable of bridging gaps, sustaining forces, and maintaining US operational readiness in the face of any challenge posed by the vast and complex theater of the Indo-Pacific. That's why China fears it so much. But what do you think? Could China possibly find a way to neutralize or counteract the Puller's significant advantages? Or will the extraordinary US Navy lead the US to victory in any scenario? China's latest naval pride, the Fujian aircraft carrier, is being hyped as a rival to the USS Gerald R. Ford, a symbol of China's growing naval power. But here's the reality: it's a total disaster. Despite its impressive size and sleek look, the Fujian is all show and no substance, plagued with critical flaws that cripple its capabilities. How did China's dream of naval supremacy fall apart? Let's break down why this so-called marvel is already China's biggest naval disaster. Let's set one thing straight right away. For most other navies around the world, the Fujian would be considered a significant achievement, a powerful aircraft carrier with advanced capabilities. After all, only 9 other countries in the world even own active aircraft carriers: France, India, Italy, Japan, Spain, Thailand, Turkey, the UK, and the US. According to James Marquez, a defense analyst at Global Data, the Fujian is certainly more advanced than ships developed by France and the UK. Even in the context of China's past naval accomplishments, the Fujian represents a major step up from previous Shandong and Liaoning designs. However, when you stack it up against the US Navy's fleet, particularly the Gerald R. Ford-class carriers it's meant to rival, the Fujian falls woefully short. The same applies when you view this ship in the context of the grand promises made and the expectations it was supposed to fulfill. What was touted as a revolutionary leap in naval power has turned out to be a disappointing letdown, failing to deliver on its lofty ambitions. But to understand how this could possibly happen, we must go back in time, back to when the US and China first developed aircraft carriers. For the US, this would take us back to 1922, when the USS Langley was commissioned as America's first aircraft carrier, marking the beginning of a tradition that would evolve into a fleet of cutting-edge carriers defining naval supremacy. For China, we would only need to go back to 2012. Yes, you heard that correctly, 90 years later. China's naval carrier program began with the launch of the Liaoning on September 25, 2012. But get this, the Liaoning wasn't even a new design, it was a refurbished Soviet carrier, the Varyag, bought from Ukraine and retrofitted for Chinese use. If you want to know about the first aircraft carrier China actually built from scratch, we would have to travel a few years into the future, to December 17, 2019, when the Shandong aircraft carrier was commissioned. That's not even 5 years ago. But now you probably understand what we're getting at. Despite the impressive strides China has made with the Fujian, the country's carrier program is still in its infancy compared to more than a century of US Navy experience and technological advancement. Simply put, the Fujian's shortcomings reflect the growing pains of a nation still learning the ropes of naval aviation. That's why it's even more bizarre how China and frankly even some Western commentators have gone about describing the Fujian. This aircraft has been described as a naval powerhouse, a major threat to US naval supremacy, and as the technology that will catapult China's naval power. So that's precisely the lens through which we need to view the reality of the Fujian. Although to be honest, it's almost surprising that China hasn't managed to achieve its ambitious goals, given the substantial investments it's poured into the People's Liberation Army Navy, or PLAN for short, as well as other branches of the military. It's all part of Chinese President Xi Jinping's so-called Chinese dream of transforming the country into a global superpower with unrivaled military prowess. To that end, between 2019 and 23, Beijing's defense expenditure was recorded at a compound annual growth rate, or CAGR for short, of 7.5%. In 2023, the CAGR stood at $230.3 billion. This impressive rate is forecast to continue with a CAGR of 6.6%, reaching an estimated $323.7 billion by 2028. When you dive into the specifics, the numbers become even more impressive. Let's take the PLAN's investment in the Type 052D destroyers as an example. Between 2023 and 28, this investment is expected to grow at a CAGR of 17.09%, rising from $765 million to over $1.6 billion. This substantial investment contrasts sharply with US spending on Arleigh Burke-class destroyers, which is projected to decline at a CAGR of -37.76% during the same period. All in all, China's Ministry of National Defense is projected to spend $1.4 trillion from 2024 to 28 on producing military hardware and modernizing its forces. Talk about a massive financial commitment. But let's see what all this money has actually delivered to China. It's time to finally meet the Fujian. The Fujian was named after the province where President Xi honed his political career, following the tradition of naming carriers after regions of strategic importance. The Liaoning was named after a northeastern province serving as a crucial navy base and a gateway to the Yellow Sea, while the Shandong took its name from the province where China's first aircraft carrier was based, a region that's played a major role in Chinese history. Interestingly, the Fujian's namesake, the Fujian province, is located on China's southwestern coast, directly opposite Taiwan across the Taiwan Strait. Knowing China, naming the most powerful aircraft carrier in the PLAN's fleet after this province certainly isn't a coincidence but a clear message. Taiwan is the focal point of the country's military posture in the region. That's why the Fujian is also expected to bolster the PLAN's East Sea Fleet, which oversees the Taiwan Strait. Construction of the Fujian began in the mid-2010s at the Jiangnan shipyard, with initial work starting around March 2015. After some delays, including issues with the electromagnetic catapults, which we'll discuss later in the video, the carrier's build progressed steadily. By September 2020, the keel and base hull blocks were largely in place, and by July 2021, the superstructure was completed. The Fujian was officially launched on June 17, 2022. On May 1, 2024, it completed its maiden voyage, with subsequent sea trials aimed at testing its propulsion and power systems lasting until May 9th, reportedly some 60 miles east of Shanghai. The fourth among these sea trials took place in September 2024, signaling that the Fujian is close to officially entering China's active aircraft carrier fleet. For comparison's sake, Liaoning underwent 10 sea trials before going into service, according to China Daily. This aligns with the Pentagon's projections, which anticipate the Fujian's commissioning within 2024. However, Taiwan's Ministry of National Defense predicts a 2025 entry into service after the completion of additional navigation tests. Regardless of the exact date, one thing's for sure. The Fujian is set to become China's largest warship, a testament to the substantial investments made in modernizing the PLAN. Now let's take a look at the characteristics of this much-anticipated vessel and how it stacks up against its American counterparts and Chinese predecessors. An important note before we start: the exact specifications of China's Fujian-class aircraft carrier, also referred to as Type 003, remain largely undisclosed, as Beijing meticulously safeguards its capabilities. However, the US Office for Naval Intelligence has managed to provide some valuable insights into its features, giving us a glimpse into what the Fujian has to offer and, let's be honest, what the vessel lacks. To the untrained eye, the Fujian and the Ford might seem nearly identical, as China's design closely mimics its American counterpart. In fact, the exterior similarities are so pronounced that anyone could be forgiven for confusing one for the other. However, this surface resemblance masks the significant disparities in their actual capabilities and performance. Let's start with the size. Given that the Fujian and the Ford are nearly identical in appearance, it shouldn't be surprising that their lengths don't differ much. The Ford, with its impressive length of 1,092 feet and width of 255 feet, is only slightly larger than the Fujian, which measures 1,036 feet in length and 249 feet in width. This makes the Fujian roughly as long as China's earlier carriers, the Liaoning and Shandong, which span about 1,033 feet. These carriers are comparable to the Kitty Hawk class carriers of the US Navy, which were 1,047 feet long and displaced about 83,000 tons. Speaking of displacement, this is where more substantial differences become apparent. The Ford, displacing approximately 100,000 tons with a full combat load, significantly outweighs the Fujian, which has an estimated displacement of around 80 to 85,000 tons, putting it in the same weight range as the Kitty Hawk class. Now, what difference does 20,000 tons truly make? Well, a lot. The weight difference affects various critical aspects of the carrier performance. The Ford's additional 20,000 tons means it sits lower in the water, which, in turn, translates to a lower center of gravity. Vessels with a lower center of gravity experience enhanced stability, which allows them to handle more aggressive maneuvers with greater control. This increased stability also means reduced rolling and pitching, thus providing a steadier platform for flight operations, as well as better performance in rough seas. Essentially, the Ford's greater displacement not only improves its maneuverability and stability, but also supports a larger air wing and more extensive onboard facilities, which we'll also discuss later on. It's also important to note that while the USS Gerald R. Ford might be the focus of attention, it's not the only US Navy aircraft carrier that surpasses the Fujian in size. The Nimitz-class carriers, which precede the Ford class, also displace over 100,000 tons, making the Fujian just the third largest aircraft carrier class globally. So much for world dominance. The last of the exterior elements we'll discuss before diving into operational capabilities is the design and layout of the carrier. In this regard, the Fujian's notable features reflect both Western influences and unique Chinese innovations. The Fujian's flight deck adheres closely to Western standards, incorporating an angled landing area and a side island. However, unlike its US counterparts, the Fujian is equipped with only two elevators, one located in front of the island and the other behind it on the starboard side. This limited number of elevators suggests that the Fujian has a smaller aircraft complement compared to the US carriers, which typically feature 3 elevators to facilitate more efficient aircraft handling and operations. Still, the Fujian has made some strides in this department. Examining the imagery of the Fujian reveals a single, pyramidal-shaped island positioned just aft of the vessel's center. This design choice highlights the carrier's focus on optimizing aircraft operations rather than maximizing ship maneuverability. This layout contrasts with other naval designs, such as the French Navy's Charles de Gaulle, which places its island more toward the fore. or the UK Royal Navy's Queen Elizabeth-class carriers, which feature 2 islands designed for conducting separate operations. In the Fujian's island, you'll find the ship's primary radars and sensors, integrated into a streamlined structure to reduce radar cross-section, well, at least as much as it's possible for an 80,000-ton warship. This setup includes panels for the ship's active electronically scanned array radar and other critical sensors. This island also houses the Fujian's integrated funnel, facilitating the expulsion of gases from the carrier's combined gas and diesel drive system, which powers the electromagnetic catapults for launching aircraft. But enough with the technicalities and design specifics. Let's shift gears to what everyone's really eager to know about: the Fujian's arsenal, air wing, and advanced technology implementations. Spoiler alert, the Fujian falls short compared to its US counterpart in every single one of these categories. First up, the armament. The USS Gerald R. Ford is equipped with a formidable array of self-defense systems designed to counter various threats. For close-in defense, there are 2 elevated Sea Sparrow launchers and 2 rolling airframe missile ram launchers, offering robust protection against incoming missiles. Complementing these are 3 20mm Phalanx close-in weapon systems, or CIWS, which can fire thousands of rounds per minute to absolutely shred approaching threats. For surface threats, the Ford is armed with 4 25mm Bushmaster chain guns and 4 50-caliber machine guns, capable of engaging small boats and attack craft. We also can't discuss the Ford's weaponry without mentioning its advanced electronic warfare capabilities, highlighted by the so-called Slick 32 Victor 6 system, which integrates both active and passive measures to detect, track, and neutralize threats through sophisticated radar and electromagnetic techniques. Additionally, the Ford is equipped with decoy launchers to mislead incoming missiles, as well as a Nixie towed torpedo decoy system, which is designed to confuse and deflect torpedo attacks, providing an additional layer of protection against underwater threats. And then there's the Fujian's weaponry, best summarized in a single expression: close, but not quite. While modern, the Fujian's self-defense capabilities fall short in several areas compared to the Ford, which immediately makes them underwhelming. Take the Ford's Sea Sparrow and Ram systems as an example. To compete with these, the Fujian reportedly features 3 18-cell guided missile launchers, potentially armed with HHQ-10 surface-to-air missiles. Compared to the Ford's heavy hitters, these missiles are less proven in combat and have a shorter range, 5.6 miles against subsonic targets and 3.7 miles against their supersonic counterparts. The Fujian may also be equipped with 2 RBU-6000 rocket launchers, which are designed to target submarines with contact-fused munitions. However, this system is considered somewhat outdated by modern standards. It's not a bad weapon per se, but it is inaccurate and thus unsuitable for precision strikes. There are indications that the Fujian might also include directed energy systems, possibly acoustic weapons, but these are not as well documented as the advanced countermeasures on the Ford. Overall, the Ford class is prepared to decisively fend off any potential threats. As for the Fujian, it might need a bit more than a few upgrades to catch up. For now, this vessel seems to be bringing a knife to a gunfight. The same sentiment persists when discussing the offensive capabilities of the 2 supercarriers. The USS Gerald R. Ford is the crown jewel of US naval might. With this in mind, it shouldn't be surprising that this colossal vessel has a carrier air wing that truly embodies a miniature air force, with each element meticulously designed to handle a wide array of combat scenarios. The Ford's air wing can carry up to 40 FA-18 ERF Super Hornets, the backbone of its fighter strength, providing both air superiority and strike capabilities. Additionally, the carrier can accommodate up to 7 EA-18G Growlers, which specialize in electronic warfare and suppressing enemy air defenses, ensuring that the Ford maintains a dominant presence in both electronic and cyber warfare domains. Adding to this impressive arsenal are 12 MH-60R Romeo helicopters, which excel in anti-submarine warfare, and 8 MH-60S Seahawk helicopters, versatile aircraft capable of a range of missions from search and rescue to anti-surface warfare. The Ford's capabilities are further bolstered by its 5 E-2D Hawkeye Airborne Early Warning Aircraft (AEW), which extend the ship's radar coverage to hundreds of miles, providing critical early detection and tracking of potential threats. Completing the air wing is the C-2 Greyhound transport plane, several of them, essential for logistical support and ensuring the carrier remains supplied with both personnel and equipment. All in all, the USS Gerald R. Ford can carry up to 90 aircraft, a testament to its unmatched operational versatility and striking power. 90 aircraft is more than some countries have in their entire Air Force arsenal. According to the Global Firepower Index, the whole of the Czech Republic has 88, while Croatia has 81, and both countries are NATO members. 90 is also at least 50% more aircraft than the Fujian can carry. While estimates on the Fujian's air wing vary from 40 to 60 aircraft, either end of the range still pales in comparison to the Ford's impressive complement. As for the specifics, reports suggest that the Fujian's air wing might include a mix of J-15 fighters and potentially the next-generation J-35 stealth fighters. The KJ-600 airborne early warning aircraft is also expected to feature on the carrier, designed to offer capabilities similar to the US Navy's E-2 Hawkeye, although the systems are still in the experimental phase. It's also worth noting that the Fujian seems to have a way to go before efficiently cycling its air wing. This should come as no surprise, as its predecessors were only limited to one type of jet and helicopter. As Marquez of Global Data puts it, when the Fujian is able to reliably cycle flights of fighter patrols alongside the AEW and anti-submarine planes smoothly, then it'll be a very close competitor to US carrier operations. For now, the Ford remains a clear winner between the two, and the Fujian, a disappointment, plain and simple. So let's not even sugarcoat it. If a battle was to take place between these two supercarriers today, the Ford wouldn't just win, it would mop the floor with the Fujian. And that's not even where the differences between these two vessels end. Believe it or not, the worst is yet to come. Here are the biggest flaws of the Fujian and its crew that truly make it a floating disaster. Number 1. The efficiency of its flight operations. The USS Gerald R. Ford can launch, refuel, rearm, and recover aircraft with precision and speed unmatched by any other carrier in the world. The US Navy has perfected these cyclic flight operations over generations, amassing an enormous amount of experience. The Chinese Navy, on the other hand, has never carried out such high-intensity flight operations. In other words, the Fujian faces an insurmountable generational knowledge gap. For context, US sailors have been conducting high-volume flight operations since World War II. That was decades before the PLAN even expressed interest in operating an aircraft carrier, let alone actually owned one. That's why the Fujian simply lacks the infrastructure and experience to match the operational tempo necessary for maintaining air superiority in a battle. Number 2. The lack of quality elevators. Now you might think the Ford has 3 aircraft elevators, the Fujian has 2. Can one elevator truly make such a difference? Absolutely. Aircraft elevators are the heartbeat of a carrier's ability to launch and recover planes rapidly. Each elevator adds critical capacity to move aircraft between the hangar deck and the flight deck, ready for launch. The Ford's third elevator isn't just a convenience, it's a game changer. It allows the Ford to cycle through aircraft faster, maintaining a higher sortie rate, and rearm jets at lightning speed. In high-intensity operations, that one elevator could mean the difference between overwhelming an enemy with wave after wave of fighter jets or being outgunned and outnumbered. And it's not even just about the number of elevators, it's also about their construction. The Ford features electromagnetic elevators, which allow for quick transport of the aircraft. Just how much quicker are we talking? 3 times faster than the hydraulic elevators used on older carriers. And can you guess who uses hydraulic elevators? That's right, the Fujian. The Fujian also has another elevator-related bottleneck, namely it lacks speedy weapons elevators. Ford's 11 electromagnetic weapons elevators are the fastest and most reliable in the world, significantly enhancing its ability to redeploy ordnance. These elevators can bring up munitions at speeds that allow for more efficient rearming of jets during combat. Number 3. The lack of quality catapult systems. Both the Ford and Fujian are equipped with the Electromagnetic Aircraft Launch System, or EMALS for short. For the Fujian, this is a huge deal, as it's the first Chinese vessel to feature EMALS, making a significant leap from the older steam-powered catapults. However, here's where the real difference lies. While the Fujian's EMALS is a first for China, the Ford has not only perfected the technology, but also incorporated it into a system designed for maximum efficiency and flexibility. That's why the Ford system is a fully operational, battle-tested platform, proven to handle a variety of aircraft types, carry heavier payloads, and require less maintenance. This carrier also features 4 catapults, one more than its Chinese wannabe contender, and we've already covered what kind of difference a single missing element makes. Number 4. The lack of advanced arresting gear. Arresting gear is the system used on carriers to safely stop and secure aircraft as they land on the flight deck. This system is crucial because the landing speeds of carrier-based aircraft can be pretty high, meaning that they could possibly overrun the flight deck and even crash without an effective means of arresting their momentum. For the Ford, this effective means is revolutionary water-arresting gear that reduces stress on aircraft, lowers maintenance costs, and increases the sortie generation rate, the latter of which is 33% higher than in the Nimitz class. The Fujian, however, still relies on traditional hydraulic arresting systems, which are prone to frequent leaks and breakdowns. In a high-tempo war scenario, the Ford's ability to recover aircraft with minimal downtime gives it a decisive edge. Number 5. The lack of dual-band radar capability. Traditional naval combat suites require several different radars to perform different tasks. For instance, one radar might track incoming threats, another might handle targeting, and yet another might search the horizon for distant objects. These separate systems then need to aggregate their data to provide a cohesive picture of the battle space. It sure would be great if one radar was able to perform multiple tasks at once, right? Well, that's precisely what the Ford's dual-band radar achieves. It allows the carrier to simultaneously track and engage multiple targets across different frequency bands, giving the Ford a much faster response time to incoming threats. This also reduces maintenance hours and simplifies upgrades. The Fujian, despite advances, doesn't possess this technology. How do we know this? Well, if they did, they would certainly announce it. Plus, China's radar systems generally lag behind, leaving the Fujian less capable of processing and responding to threats in real time, a critical vulnerability in naval warfare. Number 6. The lackluster propulsion system. The Achilles heel of the Fujian most likely lies in its propulsion system. Unlike the nuclear-powered Ford, the Fujian relies on steam turbines and diesel generators. This conventional setup not only limits its speed and range, but also warrants frequent refueling. The Ford, on the other hand, has twin A1B nuclear reactors that give it virtually unlimited endurance, capable of traveling at speeds exceeding 30 knots for decades without refueling. Yes, you heard that right. Decades. As long as it has food for the crew, fuel for aircraft, and munitions, it's good to go. And the Fujian? This carrier needs to refuel every few days to a week, severely limiting its operational range and combat readiness. This is especially disadvantageous in sustained conflict, where the ability to stay at sea and project power is vital. The Fujian's need to return to port for refueling every few days essentially makes it a sitting duck. Number 7. The lack of an underway replenishment network. Though this isn't a built-in flaw per se, it still represents a glaring weakness for the Fujian. As mentioned, the Ford can carry on as long as it has food, fuel, and munitions. Once it runs out of any of these, it can simply resupply at sea, thanks to the US Navy's extensive underway replenishment network. In contrast, the PLAN lacks a comparable system, and the Fujian would have to rely on periodic visits to ports for refueling and resupply. And as we already pointed out, this dependency is a crucial vulnerability, especially in a prolonged conflict scenario. Plus, let's not forget that China isn't exactly welcome in many strategic ports around the world. The country's geopolitical isolation essentially makes the Fujian a regional player, limited to operations near Chinese shores or artificial island chains. In a long-range conflict or global war scenario, this would severely limit its effectiveness, while the Ford could operate virtually anywhere in the world, sustained by the US Navy's and its allies' unparalleled logistical support. And there you have it, the rise and fall of China's biggest aircraft carrier, from its ambitious debut to its disastrous shortcomings. But let us ask you this: is the Fujian's ability to project power in the Indo-Pacific enough to call this project a success? We need to consider that the Ford must cover multiple theaters, so China's defensive posturing might be enough. Or do you believe that building the Fujian was nothing more than flushing a few $1 billion into the sea? Let us know in the comments section below. And while you're there, here's a bonus question. China is reportedly already building its next aircraft carrier, this time a nuclear-powered one. What are the chances this new supercarrier can give the almighty Ford a run for its money? As China seeks to further its presence in the waters of the Pacific, it has commissioned a new supercarrier to add to its fleet that they are hoping will compete with the US Navy's new Gerald Ford supercarrier. But how does the Fujian compare to the Navy's newest addition to its carrier fleet? Does it have the technological capabilities to compete with modern blue water carrier fleets? What is the likely military doctrine that will outline its use in battle? In this video, we will seek to answer these questions and more. Let's delve right in. Much of what we know about the new Fujian is based on reconnaissance imagery and intelligence analysis. The Chinese Type 003 Fujian supercarrier has a 316-meter flight deck and has a beam of 76 meters at the flight deck. It is conventionally powered by 8 boiler steam turbines, producing approximately 220,000 horsepower at its 4 shafts. The Fujian is expected to utilize electromagnetic catapults, a step up from the ski jump configuration of its predecessors. Its displacement will be about 80,000 tons with a full combat load, though recent intelligence suggests that it may actually displace closer to 100,000 tons. The ship will be crewed by approximately 2,000 sailors and 60 flag staff officers. The endurance of the Fujian is not yet known, however. The Type 002 carrier Shandong has a top speed of 31 knots and a range of 25,928 kilometers, 16,000 miles, at 14 knots. Similar performance is expected from the Fujian, though top speed is slightly slower at 29 knots. Construction on the Fujian began sometime in the 2010s, though the exact date is currently unknown. Construction was paused briefly as the electromagnetic catapult system was developed, but resumed again in the late 2010s. The ship's modules went into dry dock in mid-2020, and reports were that a launch of the vessel was possible by mid-2022. These reports turned out to be accurate, as the Fujian was launched on 17th of June 2022, sporting the hull number 18. The Electromagnetic Catapult Aircraft Launch System, or EMALS as the US refers to it, utilizes a linear induction motor as opposed to the steam piston catapults of other carriers. This represents a significant technological jump for the Chinese, as they have skipped developing conventional steam-driven catapults altogether. The new system has several advantages over steam piston systems, chief of which are reduced stress on the airframe due to a more uniform acceleration, as well as being lightweight, easier to maintain, and faster to reset. The development of the EMALS system was spearheaded by China's top naval engineer, Rear Admiral Ma Wei-ming. The new catapult system will allow the launch of larger and heavier aircraft. The aircraft carrier is expected to utilize a modified J-15 fighter variant for its main fighter wing, until a dedicated fifth-generation fighter can be developed for carrier-based operations. In 2021, intelligence analysts concluded that the People's Liberation Army had developed the J-15B, which includes CATO bar, or Catapult-Assisted Takeoff but Arrested Recovery. The new variant also included an upgraded avionics suite, newer engines, and the ability to launch upgraded missiles. The fighter air wing is expected to consist of 55 modified J-15 fighters. The J-15 carries a crew of 1 to 2 depending on variant and mission. It has a length of 22.8 meters, 73 feet and 1 inch, and a wingspan of 15 meters, 49 feet and 3 inches. It has a gross weight of 27,000 kilograms, 59,000 pounds, and a max takeoff weight of 32,500 kilograms, 71,650 pounds. Max speed is reportedly Mach 2.4, with a ferry range of 3,500 kilometers, 2,200 miles. The aircraft reportedly uses 2 WS-10B turbofan engines. The engines are equipped with afterburners and each produce 30,000 pounds of thrust with afterburners lit. The J-15 is capable of carrying the following ordnance: 1 GSH-31 30mm cannon with 150 rounds, PL-15 long-range air-to-air missiles, PL-12 medium-range air-to-air missiles, PL-10 short-range air-to-air missiles, YJ-83K anti-ship missiles, KD-88 standoff land attack missiles, YJ-91 anti-radiation missiles, plus assorted bombs and rockets. The aircraft is also capable of utilizing the UPAS-1A buddy refueling pod similar to F-18s in the US carrier fleet. The air wing is also expected to employ prop-powered transport aircraft and KJ-600 AEW and C airborne early warning and control. The KG-600 was specifically developed to take advantage of the Fujian's upgraded catapult system and will lessen the carrier's reliance on helicopters for AEW and C operations, as well as anti-submarine operations. The aircraft is the direct counterpart to the American E-2 Hawkeye and fills a similar role. The new aircraft made its maiden flight on 29th of August 2020, with flight testing continuing into 2021. The KJ-600 is a high-wing turboprop aircraft fitted with a large overhead radome. It's suspected that the radome houses an AESA-type radar system in a 3-way configuration. It has a crew of 3 to 5 airmen. It is 18.14 meters long, 59 feet and 6 inches, and has a wingspan of 25 meters, 82 feet. The tailplane is a quad-fin configuration for increased stability. The aircraft is powered by 2 Zuzu Wojiang 6C turboprop engines. each producing 5,103 horsepower. The engines spin 6-blade constant-speed feathering props, which are capable of pitching to reverse thrust. The aircraft has a max gross weight of 30,481 kilograms, 67,000 pounds, and an empty weight of 25,401 kilograms, 56,000 pounds. It has a stated range of 1,250 kilometers, 780 miles, and a ferry range of 2,800 kilometers, 1,700 miles. The KG600 has a max speed of 693 kilometers per hour, 431 miles per hour, and a service ceiling of 15,000 meters, 50,000 feet. It's also possible that the air wing will consist of unmanned aerial vehicles, UAVs, and helicopters. It's anticipated that the air wing will consist of approximately 1,000 airmen. Defensive capabilities are expected to include 3 30mm close-in weapon systems, CIWS. These weapon platforms are to be outfitted with AESA radar and are able to intercept anti-ship missiles traveling at Mach 4+ with 96% accuracy. It's also believed that the carrier will employ short-range air defense missiles and anti-submarine rocket capabilities. While the Fujian has already been launched, it's not expected to be ready for combat operations until 2024 or 2025. Even still, the Fujian is expected to be the most capable non-US aircraft carrier deployed to date. It represents a giant leap forward for China's Navy, but is it enough to stand toe-to-toe with the United States? Well, one important factor to consider is how the carrier will be utilized. China does not have much experience in carrier operations. While the United States has the benefit of 100 years of experience, China is in a rush to play catch-up. Launching and recovering aircraft in all weather and lighting conditions is something that takes practice, solid operating procedures, and delicate orchestration. Reports indicate that as of now, Chinese aircraft still utilize land-based airfields precisely because of these shortcomings. They also lack experience in anti-submarine warfare and anti-ship missile detection and engagement. Though the KJ600 aircraft is being developed to deploy with the Fujian, it's not yet fully operational. Due to the fact that the carrier has conventional propulsion systems, it must cruise with a fuel tanker for sustained operation, exposing yet another vulnerability. Because of these factors, the carrier is likely to be utilized in regional waters in show-of-force operations, but lacks the experience, technology, and capability for effective and sustained combat operations in distant waters away from mainland resources. This effectively limits its use as a blue water Navy flagship in the modern arena. Gerald R. Ford-class supercarriers are the United States' latest carrier class, set to replace the current fleet on a one-for-one basis. It's expected that 10 carriers will be built and launched over the course of the upgrade process. It's expected that all 10 carriers will have combat capability by 2040. The first ship, the USS Gerald R. Ford (CVN-78), began construction in 2005, was launched in 2013, and was commissioned in 2017. CVN-78 is replacing the USS Enterprise (CVN-65). CVN-78 has a 337-meter flight deck with a 78-meter beam, just slightly larger than the Fujian. It utilizes 2 nuclear reactors for power and can reach speeds in excess of 30 knots. The nuclear power plant provides the Gerald Ford with an unlimited range. The ship utilizes 4 electromagnetic catapults, as well as an advanced arresting gear system. Displacement with a full combat load is at 100,000 tons, and has a complement of 508 officers and 3,789 enlisted men. The air wing employed on CVN-78, CVW-8 or Carrier Air Wing 8 consists of 4 Super Hornet squadrons, an E-2 Hawkeye squadron, an EA-18 Growler squadron, C-2A Greyhound squadron, and 2 MH-60 helicopter squadrons. At the time of this video, there are currently no 5th-generation F-35 Lightning II fighters attached to the air wing. However, this capability would not be difficult to add in the future, as the F-18 begins to be replaced by the multi-role fighter. The F-18 Super Hornet is a supersonic twin-engine multi-role fighter. It is considered a 4th-generation fighter, which puts it in the same class as the J-15B. The Super Hornet has a crew of 1 to 2 depending on variant and mission. It has a length of 18.31 meters, 60 feet and 1.25 inches, and a wingspan of 13.62 meters, 44 feet and 8.5 inches. Max takeoff weight is 29,937 kilograms.
66,000 pounds, and has an empty weight of 14,552 kilograms, 32,000 pounds. The aircraft is capable of reaching 1.6 Mach and is powered by two General Electric F414-400 afterburning turbofans. Each engine is capable of producing 22,000 pounds of thrust with afterburners lit. It has a range of 2,346 kilometers, 1,458 miles, and a combat range of 822 kilometers, 511 miles. The fighter is armed with one 20mm M61A2 Vulcan cannon and 412 rounds of ammunition. It carries 4 AIM-7 Sparrow missiles, 4 AIM-9 Sidewinder missiles, 12 AIM-120 AMRAAM missiles, and 12 AIM-260 JAT-M missiles. It can also carry 6 AGM-65EF Maverick air-to-ground missiles, 4 AGM-84H Ki SLAM-ER missiles, 6 AGM-88 HARM missiles, 4 AGM-158 JASSM missiles, 4 AGM-154 Joint Standoff Weapon JSOW glide bombs, 4 AGM-84 Harpoon anti-ship missiles, 4 AGM-158C LRASM missiles, JDAM bombs, laser-guided bombs, Mark 80 series bombs, and CBU-78 Gator mine systems. As far as avionics, the Super Hornet utilizes either the Hughes APG-73 or the Raytheon APG-79 radar systems. It also carries either the Northrop Grumman ITT ALQ-165 self-protection jamming system or the L3 Harris AN ALQ-214 integrated defensive electronic countermeasure system. The Raytheon AN ALE-50, BAE AN ALE-55 tow decoy, Raytheon AN ALR-67 radar warning receiver, and the MIDS LVT JTRS data link transceiver are also carried. The E-2 Hawkeye is the US Navy's aircraft for AEW&C operations, as well as anti-submarine operations. The Hawkeye is a high-wing, quad-tail, turboprop-powered aircraft. In looking at its physical appearance, you can see where the inspiration for the KJ-600 came from. It also has a large radome affixed above the wing. The aircraft first saw service on 21 October 1960 and has undergone many modifications and refinements since that time in order to meet the needs of the current battlefield. The current model E-2D has aerial refueling capability. It is 17.6 meters, 57 feet, and 8.75 inches long, and has a wingspan of 24.6 meters, 80 feet and 7 inches. It has a max takeoff weight of 26,082 kilograms, 57,500 pounds, and is powered by two Allison Rolls-Royce T59A427 turboprop engines. It has a 6-hour operational endurance time at sea, allowing sustained command and control operations. The C-2 Greyhound is a transport variant of the same aircraft. It's responsible for carrier onboard delivery (COD) operations. CVN-78 hosts a robust defensive weapons suite designed to protect the carrier from multiple avenues of attack. These include 2 Mark 29 guided missile systems, 2 Mark 49 guided missile systems, 3 Phalanx CIWS gun platforms, 4 Mark 38 25mm machine gun systems, and 4 M2 50 caliber machine guns. The defensive systems are tied together by upgraded AN Spy-3 X-band multifunction radar and AN Spy-4 S-band volume search radar. These systems are all tied to the SSDS or Ship Self-Defense System. This system has the ability to automate the fire control loop, which shortens the response time from detection of a threat to engagement of the threat. The Supercarrier also has stealth features, which are designed to reduce its radar cross-section. An additional feature of the carrier is the placement of the island, the superstructure which houses the bridge, air traffic control, and command center. The island has been placed aft on the carrier, opening up more space on the flight deck for aircraft to taxi. This change is expected to increase aircraft launch and recovery by nearly 30%. This increased efficiency allows for more sorties to be safely launched than the previous Nimitz-class supercarrier. The US Navy has been operating carriers since 1922, with the launch of CV-1, the USS Langley. With over 100 years' experience, the United States Navy has perfected the intricate ballet that is carrier operations. The current US Navy is capable of carrying out combat operations for extended periods of time before resupply day or night, in all manner of weather. China lacks this experience, however, they have the distinct advantage of trying to emulate the US Navy's operations procedures, technical capabilities and proficiency. While they are aggressively playing a game of catch-up, at this stage it does not appear that they are at the same level as the United States. First, this is evident in the technological capabilities of the equipment they have deployed. The carrier, while large and technologically advanced as compared to the Type 001 and Type 002 carriers, has some serious shortcomings. It only has 3 catapults as compared to the Ford's 4. It does not have as robust a defensive electronics and weapons suite as the Ford. Perhaps its biggest shortcoming, however, is the propulsion system. Being conventionally powered, it must either cruise with a tanker for blue water operations or remain in regional waters, so the carrier would have to protect both itself and its fuel supply. This is a major blow to its combat capability, so the Fujian is likely to patrol regional waters well within the range of shore-based assets that can offer resupply and tactical assistance. This, combined with the strike group that carriers sail with, would offer enough protection to overcome these shortcomings, but at the expense of global reach. This may be good enough for the Chinese, as they may not necessarily be interested in global reach at this point. As President Nixon once stated, the Chinese tend to be firmly focused on China first, even at the expense of political doctrine. This is evident when viewing the alliances they hold, as they don't necessarily fall along the lines of political or economic dogma. So if they are primarily concerned with showcasing military might regionally, then the Type 003 may in fact fit the bill. Having said that, there are other areas that continue to hamper the effective use of the Fujian, beyond the capabilities of the carrier itself. The air wing seems to lag behind the United States in terms of capability and effectiveness. In comparing the J-15 to the F-18E, for example, the United States clearly has an edge. This advantage extends to not only the aircraft's capabilities, but in terms of ordnance carried, mission capabilities, and defensive capabilities. The Super Hornet has had the luxury of time to grow and mature, standing on the shoulders of the original F-18 and the experience gained from the F-14 program. The upgrades are purposeful and well thought out to suit the needs of the Navy and the US Department of Defense as a whole. It would seem that the upgraded J-15 had a less focused development and seems to be more haphazard without a clearly defined role. Sometimes more isn't always better, it's just more. The KJ-600, while very similar in aesthetic to the E-2 Hawkeye, doesn't have the same loitering time and avionics suite. It's true that the Chinese government has kept a tight lid on its capabilities. On the surface, it comes off as a less capable clone. Military technology will only get you so far, however. Tactics and training are often what wins the day. It is in this area where the largest difference between the two carriers and sailors on board is evident. As previously stated, the US Navy has been operating combat-capable aircraft carriers for 100 years. They have seen combat operations in World War II, Korea, Vietnam, the Middle East, the Balkans. The sailors on board train relentlessly to maintain a state of combat readiness that is based on experience and lessons learned in the high-stakes world of warfare. The Chinese do not share this experience or advantage. No Chinese carrier fleet has actively participated in combat operations. They have simulated strikes on islands. However, they don't have the real-world experience to adequately simulate the pressures of sustained operations where lives are at stake. The PLAN affords the average pilot 100 to 150 hours of flight time annually. US pilots, by contrast, typically fly 200 hours per year. US pilots and sailors are able to conduct combat operations anywhere, at any time, and in all manner of weather. Chinese pilots to date lack this capability. The United States also spends much time and resources training the carrier strike force to operate as a cohesive unit. Through years of experience, procedures, information flow, and command structure have all been carefully crafted to operate globally with extreme effectiveness. It is unknown how much China invests in cohesive combined arms training, but it would have to be overt and extreme to compete with the level of training the US fleet employs. Taking all these considerations into account, it's clear that if we were dealing with a carrier-to-carrier engagement, absent additional naval and mainland support, things would most likely end badly for the Fujian. However, when adding the support that the Chinese have available regionally, it's interesting to consider what would happen in a regional engagement between the two navies. If one were to conduct a thought experiment into what would happen if China were to take hostile action against Taiwan, we would first have to make some assumptions to get an idea of the playing field. First, let us assume that the Fujian would commence the engagement in the Taiwan Strait. Let's also assume that the Gerald Ford strike group was operating independently without support of additional carrier groups. Also, let us make the assumption that additional aircraft would not be provided by the Chinese mainland Air Force. Finally, let's assume a conventional, non-nuclear conflict where hostilities are already occurring and the rules of engagement allow for the full use of force. It would seem logical that the first order of business would be to establish air superiority and to limit the Fujian's mobility. This would mean removing its tanker from the fight through either subsurface, surface, or aerial means. The Ford has approximately 48 strike fighters available and can launch between 160 to 270 sorties a day. The Fujian has 40 strike fighters available, and based on existing figures from the Type 001 and 002 carriers, can launch 20 sorties per day, based on numbers gleaned from training exercises. This vast disparity of flight operations indicates that the Fujian Air Wing would likely be overwhelmed in actual combat conditions. This simple math does not take into account the early warning detection and electronic warfare capabilities the Ford enjoys. To further exploit the Fujian's weaknesses, the Ford would likely commit to night operations or foul weather operations that would further wreak havoc on the Chinese air wing. With its air wing decimated and an inability to maneuver, the Fujian's contribution to the fight would be marginal at best. From this standpoint, the Fujian seems like a paper tiger. But the reality is that the constraints that we put in our analysis are unlikely to exist in reality. The Chinese mainland forces would be unlikely to allow their fleet to be encircled and besieged. Likewise, the United States is unlikely to enter the fray without the support of allied nations or an additional carrier strike group. It is conceivable that in addition to Taiwan, Japan, the Philippines, South Korea, Thailand, and even Vietnam would offer aid if not join the fight outright. The risk of the incident turning into a global conflict is very real and not to be taken lightly. However, even in this scenario, it seems unlikely that the Fujian would come out on top, especially if the conflict extended out into what is considered the second island chain. Current analysis seems to indicate that the Fujian serves a political role and a way of flexing regional muscle as a means of intimidating East and Southeast Asian countries, as China continues its effort to expand what it considers its territorial waters, a regional show of force that would augment the man-made islands and the airfields they have placed as footholds in disputed waters. In November of 2023, the Type 002 carrier Shandong and its strike group operated in the Taiwan Strait for 2 weeks and flew 420 J-15 sorties. This show of force, however, does not likely indicate an imminent threat to Taiwan, but can be used to assess how the Fujian is likely to be utilized. Analysts have also concluded that unlike the United States' use of the Ford as an offensive asset, the Chinese have adopted the Fujian as a defensive asset, specifically as it comes to the first island chain off the coast. China has placed most of its development and deployment on the ability to launch shipborne cruise missiles. It's likely that the carrier air wing is intended to protect these ships from attack, rather than offensively engaging targets like the United States doctrine. The Department of Defense has indicated that while they do not believe China currently has the capability of successfully invading Taiwan, they may by 2027. This is per testimony presented to Capitol Hill by Admiral Phil Davidson. One thing that is evident is that while that may be the case now, it's not something to be taken for granted. China is aggressively working toward creating a truly capable blue water navy. Ship to ship, China does have the largest navy in the world. They also possess superior industrial capabilities and can build and launch ships twice as fast as the United States. The next carrier in Chinese development is purportedly slated to be nuclear-powered, larger and with a more capable air wing. China is already looking at upgrading the J-15 air wing to a fifth-generation air wing and has successfully test-flown the J-35. The J-35 is the Chinese counterpart to the American F-35. We can only hope that the two superpowers never have to engage fleet to fleet. In addition to the catastrophic loss in life that a conflict of this magnitude would create, the economic impact on both countries would be catastrophic. Both countries have economies that are heavily dependent on each other. China owns majority shares in several US-based businesses. These facts make employing the calculus of war tricky, as the United States has never been in an adversarial position quite like this before. Only time will tell how the story will unfold. But what do you think? What would happen if China and the US found themselves in a fleet-to-fleet confrontation? Who would win? China wants to make itself the world's leading economic and military superpower by 2049. But there's a big problem. It's trapped by its own geography. It sits behind a series of island nations hostile to its foreign policy ambitions. These islands potentially serve as staging points to cut off its commerce and send any military force back to the Chinese coastline. Because of its geopolitical vulnerability, China has invested heavily in its missile force and naval buildup. It's expanded its naval fleet, which now includes 3 aircraft carriers, with a 4th on the way. China has not yet attempted to break its containment within the first island chain, but it has flexed its new naval muscle to militarize and fortify the sea lanes within it. China's increased militarization of the area has prompted the United States to respond with freedom of navigation operations, FONOPs, to challenge its territorial claims and prevent its military from achieving local supremacy. But what if one of these FONOPs went horribly wrong and a naval battle erupted in the South China Sea? In that case, you would need to ask one question. What would an attempt by the US Navy to sink a Chinese aircraft carrier look like? Here's a scenario. Suppose it's the winter of 2025. Tensions continue to boil in the South China Sea as Chinese ships interfere with Filipino vessels in the Philippines' internationally recognized exclusive economic zone under the terms of the United Nations Convention on the Law of the Sea, UNCLOS. Collisions between Chinese and Filipino vessels have become increasingly common over the last year as the former attempts to bully the latter out of the waters. It may start innocently enough. A Filipino fishing boat is coming close to the Scarborough Shoal. Under UNCLOS, this area is part of the Philippines' exclusive economic zone, but China seized the shoal in 2012 and has controlled it ever since. Chinese ships have rammed Filipino boats trying to enter the shoal's lagoon before, but this time they are particularly aggressive. 2 Chinese Coast Guard ships sink the Filipino fishing boat, prompting a response from the Philippines Navy. In response to the incident, the People's Liberation Army Navy steps up its patrols in areas Manila disputes with Beijing. The Philippines have a mutual defense treaty with the United States and hosts several American military bases. To show its resolve in protecting its ally, the US Navy responds with a FONOPS that will skirt the highly disputed Spratly Islands. One of the Navy's Arleigh Burke-class destroyers will take the lead in the exercise. As expected, the PLAN shadows the American destroyer, which comes within 10 miles of China's artificial islands. 2 Type 054A frigates, on alert from the earlier tension with the Philippines, attempt to block the Navy's ship, and this time, a collision cannot be avoided. Both countries point fingers at the other. China claims that the United States has violated its territorial integrity, while Washington says Beijing was violating international maritime law. With the increasing hostility in the area, China sends one of its aircraft carriers with its accompanying battle group to the area, but Beijing wasn't the only one with such ideas. The United States sends one of its carrier groups to the area too. Submarines from both sides are also present beneath the waves. The increasing militarization of this confined area makes further accidents a lot likelier, and one soon comes. Under international maritime law, military vessels cannot engage in reconnaissance, jam signals, or use weapons. Doing so means they will lose their innocent passage status. Since the US Navy is there to uphold international law and does not want to get into a broader confrontation, it respects these prohibitions, even if doing so will make it vulnerable. China does not want a confrontation either, but it has a different objective. It wants to undermine international law and strengthen its grip on the South China Sea by bullying others out of the area it claims under the 9-dash line. The Chinese carrier attempts to project power by launching a patrol of J-15 Flying Sharks. Despite this show of force, the US Navy remains vigilant. The fortified islands also launch aircraft in support, but the advanced radar and early warning systems of the American carrier group easily track these moves. While the Chinese aircraft approach dangerously close to some US Navy vessels, their maneuvers are reckless and lack the sophistication of their American counterparts, who calmly prepare to counter any aggression. The US ships equipped with superior defensive systems maintain their position, forcing the Chinese to reconsider their approach. The US Navy responds by scrambling FA-18 Super Hornets in addition to the ones routinely patrolling. Unfortunately, as has been the case in the past, the aircraft come dangerously close to one another and again a collision occurs. One of the Chinese pilots loses his nerve after this and launches a missile, fearing he will also be impacted. From that moment, the 2 flights engage each other in air-to-air combat. Things escalate further. One of the Chinese ships gets involved and launches a salvo of HQ-16A surface-to-air missiles at the Super Hornets in flight. These missiles have an operational range of 40 kilometers and a speed of Mach 3. They're not as capable as the US Navy's RIM-162 SM missiles, which can hit targets 50 kilometers away at a speed of Mach 4, but they add to the confusion and take some of the Super Hornets by surprise, destroying one of them and forcing others to retreat, with more enemy aircraft coming. The Super Hornets, momentarily focused on air-to-air engagements, strategically avoid the Chinese ships, knowing that reinforcements armed with ship-destroying capabilities are already en route. The US Navy's ability to adapt rapidly ensures that any surface threat will be neutralized efficiently once the appropriate assets arrive. The US Navy now has an objective forced on it. It must destroy the PLAN aircraft carrier before casualties balloon. Diplomats in Washington and Beijing have almost certainly reached out to one another by now to try and defuse the situation, but the carrier group's commander cannot expect that to happen in a fast enough time. Protecting the Navy's sailors has to be the top priority. Fortunately, the American carrier would have been ready for this, given all of the tensions in the area. More Hornets would have been on standby and equipped with RGM-84 Harpoon anti-ship missiles. 2 squadrons of these would be ready to go. Another squadron of Hornets would be on alert and ready to be armed with anti-air or anti-ship missiles within an hour. The Hornets would now engage the lead Chinese ships with their Harpoon missiles. These missiles skim close to the waterline at subsonic speed. Some of them would be countered by the Chinese ship SAMs, but the flight of Hornets would have launched too many Harpoons, and just a few hits at a ship's waterline would be enough. At least one of the forward-deployed Chinese ships would go down. Meanwhile, the remaining J-15s would be engaged and either shot down or forced to retreat by the Super Hornets that now significantly outnumber them. The squadron will fly north toward the Chinese carrier. China scrambles a large squadron of its planes, including J-15s and land-based aircraft like the J-11 and J-16, in an attempt to counter the superior US aircraft. These planes are armed with the PL-15 missile, which, while boasting a long range and high speed, lacks the battlefield versatility of the US's well-tested AMRAAM. Although the AIM-260 JATM is not yet widespread, the American pilot's superior tactics and the US Navy's advanced electronic warfare systems negate much of the PL-15's potential advantage, turning what China hoped would be a strength into a mere parity at best. As soon as they detect the Super Hornets, they open fire. The American pilots are now in a bind. Logic would indicate that they would need to take evasive maneuvers immediately. However, these are all highly trained naval aviators. They know that they need to give their missiles the highest kinetic energy possible in order to maximize their effectiveness, so they would likely move as close as they could, fire their own missiles, and then take those evasive maneuvers. The PL-15 missiles have weaknesses, which are quickly exploited by the experienced American pilots. The long-range shot causes the missiles to lose significant energy, which, combined with the US pilots' tactical maneuvers, render the PL-15s ineffective. The Super Hornets' advanced countermeasures and the thicker air at low altitude further degrade the missile's performance. As a result, the American aircraft suffer minimal damage, while the poorly coordinated Chinese forces face significant losses in the ensuing engagement. Many of the Chinese aircraft will be armed with the PL-12. This missile entered service in 2005, but was developed at a time when China was still a military backwater. This missile only has a range between 70 and 100 kilometers. Super Hornets armed with AMRAAMs would outshoot these missiles, and it's unlikely that any of them would be destroyed in return. The Super Hornets also have an advantage in their radars. Many of the Chinese aircraft would likely not know they're being targeted until the AMRAAM's radar activates near the end of the projectile's flight path to their targets. However, an initial confrontation like this would not result in the loss of the Chinese aircraft carrier. There wouldn't be enough momentum to get to it. As the initial battle goes on, Chinese fighter aircraft will be launched from Hainan Island to reinforce their comrades. H-6 bombers would also take off to provide additional firepower in an effort to destroy the American carrier. Unfortunately for the US Navy, this will be a vulnerable point, as many of the Super Hornets would have shot their payloads at this point and would need to return to the carrier to rearm. However, a few would remain circling around the disputed airspace to provide a forward presence. As the previous aircraft returned to rearm, the remaining Super Hornets on the carrier would be armed and ready to go by now. Each one will be equipped with at least 9 air-to-air missiles, but they need to take off before the Chinese aircraft get too close. E-2D Hawkeye AWACS aircraft in the area would have given the carrier's captain warning that a large number of enemy planes were on their way, redoubling the urgency of rearming and relaunching the Super Hornets. These would get into the sky and move as far away from the American carrier as possible to keep the Chinese aircraft at bay. Unfortunately, the Hawkeye is soon destroyed by Chinese missiles, so the American aircraft would need to rely on other sources of information. The squadrons from the American carrier versus the Chinese land and sea-based aircraft would now become the largest air battle of modern times, and the missiles flying through the sky would easily be a volley unlike anything seen in history. Fortunately, even without the Hawkeye, the American aircraft will be well informed. The FA-18 comes with an AN/APG-79 radar. This is an AESA radar that allows a track and scan ability to lock on and fire at multiple targets with ease. The Chinese aircraft will be at a disadvantage with their radars. China is a relative newcomer with advanced radars, and many of their older planes like the J-11 would be in the sky in this fight. Not all of them would be armed with the PL-15 either, but rather the obsolescent PL-12. The result is that many more of the Chinese planes will become casualties than their American counterparts. However, after this engagement, the Super Hornets would be out of missiles and again be forced to return to the carrier. The carrier is now even more vulnerable than the first such instance because there will be few, if any, American aircraft in the vicinity to stop the Chinese planes. The tyranny of distance has now entered the arena in a big way. China has the advantage of fighting close to its homeland. Its supply lines are therefore shorter, and it can bring more assets to the fight on a moment's notice. In contrast, the United States can only fight with what it has on hand at the moment. It needs to ship supplies and reinforcements over thousands of miles. The remaining aircraft from the Chinese mainland would still be large in number, more easily replacing losses. Each American aircraft loss is temporarily irreplaceable. The Chinese ships would also soon come into range. These would now launch their YJ-18 cruise missiles. These projectiles have a range of up to 540 kilometers and are normally subsonic in velocity, but there is a catch. In the final approach phase, a solid rocket booster brings their speed up to Mach 3. They fly near the waterline, making them hard to shoot down and more destructive when they hit their targets. The Chinese bombers from the mainland would launch their own anti-ship cruise missiles, and the YJ-83K in conjunction with the ship-launched YJ-18s. These are slower, remaining at subsonic velocity, and come armed with a 190-kilogram high-explosive warhead. The two types of anti-ship missile would complement each other though. The American carrier's escort ships would first fire their SM-6 surface-to-air missiles to intercept the incoming Chinese projectiles. These missiles have a range of 370 kilometers, making them ideal for destroying projectiles at long range. Several volleys of these missiles will be launched at the Chinese missiles and aircraft, with a high rate of successful interceptions. However, these missiles would eventually be depleted in the face of such a huge Chinese volley, and the carrier escorts would need to resort to other measures. Shorter-range RIM-162 SM missiles would move into action. These have an estimated operational range of 50 kilometers and a speed of Mach 4. However, there would be other problems, because these are not the only projectiles the American carrier group would need to deal with. DF-21D anti-ship ballistic missiles will be launched from Hainan. These missiles have a range of 2,150 kilometers and a 600-kilogram high-explosive warhead with a speed of Mach 10. These are difficult to intercept, but the escort ships also have SM-2 missiles as part of the Aegis weapon system aboard Ticonderoga-class cruisers and Arleigh Burke-class destroyers. These interceptors have a ceiling of 24.4 kilometers, a range of 185, and a speed of Mach 3.5. This hail of interceptors would have a high success rate in countering most of the Chinese cruise missiles. However, some would impact, and more ballistic missiles would. Some of the American ships would go down, as there are simply too many missiles. There is likely no avoiding this scenario. However, while China has the tyranny of distance on its side, it also has a big disadvantage. China's surface ships consist mainly of smaller vessels like frigates and corvettes. This is why it remains significantly behind the US Navy in terms of tonnage. The Chinese ships would not be as survivable, and Super Hornets armed with harpoons would engage and destroy several of the Chinese carriers' escorts. To make matters worse for China, the United States has a Seawolf-class nuclear attack submarine in the area that now swings into action. America's nuclear subs are not so easy to destroy with missiles, and they are much quieter than the Chinese subs. The American submarine gets into position and launches its Mark 48 guided torpedoes against more of the Chinese escort ships, and its harpoon missiles at the Chinese carrier. Escort ships detect and intercept these, but there's more to come. Meanwhile, the Chinese missiles impact the American ships, damaging the American carrier. However, Super Hornets are now in the sky along with another weapon, the F-35B. While the Hornets engage the Chinese escort ships, the F-35Bs are armed with AGM-158 long-range anti-ship missile, LRASM. The LRASM likely has a range of 370 kilometers, and to make matters better, it's difficult for radar to detect. Although China has come a long way in aviation and radar, it's still significantly behind the United States in stealth technology and countermeasures. While the Hornets engage the Chinese missiles and fighters, the F-35s move in. They choose to not use the missiles at their longest range, instead preferring to evade detection until the last moment to give their projectiles as much energy as they can when striking their target and to give the enemy less time to respond. The F-35s launch their missiles at a range of 60 kilometers and speed away. The Chinese carrier's crew, already rattled from the harpoon attack, does not know that this was only the first salvo coming at it. The carriers detect the F-35s when they attack, but the missiles remain stealthy. The LRASM is also guided by artificial intelligence to plan its own attack, if need be, and break through enemy electronic warfare countermeasures. The LRASMs impact the Chinese carrier with their 450-kilogram warheads and strike the target near the waterline. The Chinese sailors have no choice but to abandon ship as it sinks. The remaining Chinese aircraft are running low on fuel and have to return to Hainan. Meanwhile, the Super Hornets and F-35s have no carrier to return to either, so they decide to make a break for Filipino territory. A few of the F-35s were shot down after they were detected launching their LRASMs. By the end of an engagement like this, thousands of sailors and aviators would be dead or wounded on both sides. Diplomats in Washington and Beijing would be scrambling to try to prevent this battle from becoming a wider regional war, but with the loss of so many thousands and billions of dollars worth of equipment, finding a way for both countries to save face would be difficult. This scenario shows that for all its advancements, China's military still cannot match the United States in a direct confrontation. In a scenario involving an aircraft carrier battle, China's lack of stealth and radars that can match the United States would likely play out in a big way. China's escort ships would also be more sinkable and carry fewer weapons than their American counterparts because they are significantly lighter. However, the cost of defeating a Chinese force is a lot higher than it was 10 years ago, let alone 20. Its home field advantage and arsenal of land and ship-based ballistic and cruise missiles have made naval operations in the area much more dangerous. In this scenario, the Chinese carrier is sunk, as are many other ships in the PLAN, but at the cost of many American ships and planes too, including a heavily damaged carrier that the US Navy can only hope will be salvageable. For now, the United States' advantage in stealth and submarine warfare should allow it to have an edge, but China has new nuclear submarines coming and more hypersonic glide vehicles coming online. The arms race in the Indo-Pacific continues. What would the environment against the Chinese carrier group look like in the 2030s?
Stealth bombers scorch across the sky. Missiles rain down, destroying everything of importance all over China. The Chinese military is in full panic mode because there's nothing they can do to prevent it. This is what happens when B-21 raiders attack China. That scenario is the focus of an amazing CGI simulation on the MilSim-K channel, which specializes in high-quality and realistic simulations of military clashes. The video showcases the destructive power and next-level maneuverability of the world's first 6th-generation military aircraft. The B-21 has been touted by some to change the global balance of power, especially around Taiwan and the South China Sea. So to say the US's adversaries, particularly China, are taking the threat very, very seriously is an understatement. We'll delve into how the Chinese are scrambling to react to the B-21 and why they're so concerned a bit later. But first, what happens in the simulation when a squadron of B-21s is unleashed to attack the Chinese mainland? The confrontation starts when the Chinese military conducts a provocative large-scale military demonstration in and around the Taiwan Strait. Picking up the massive military buildup via its network of spy satellites, the US dispatches an aircraft carrier group to monitor the situation. The People's Liberation Army, or PLA for short, decides to take the initiative and fires a large barrage of DF-21 missiles at the US Navy aircraft carrier group from the row of transport erector launchers, or TELs, it's assembled on the shore. The DF-21, short for Dongfeng 21, is a family of Chinese medium-range road-mobile ballistic missiles developed in China, also known by their NATO reporting name CSS-5 Dongfeng. In 2013, the DF-21D variant was successfully tested against a ship target roughly the size of a US aircraft carrier, and in 2016, the US Department of Defense revealed a new nuclear variant, the DF-21E, also known as CSS-5 Mod 6. The sudden DF-21 attack panics the US Navy group, which attempts evasive maneuvers and fires off interceptor missiles. Fortunately, it's difficult for ballistic missiles to hit moving targets, and the Navy aircraft carrier narrowly escapes being hit. The barrage of DF-21s falls harmlessly into the sea. Enraged, the US Navy prepares a counterattack, and 4 hours later, it's showtime. A squadron of B-21 bombers from the US 8th Air Force swoops down ominously on the Fujian coast of China. The Northrop Grumman B-21 Raider is the successor to the B-2 Spirit stealth bomber, and a significant upgrade too. It's a long-range stealth intercontinental strategic bomber able to deliver conventional and thermonuclear weapons, but also able to function as an intelligence collection platform, battle manager, and interceptor aircraft. Although many of the details are still classified since the aircraft is still in development and testing, it's known to have a length of 54 feet, a wingspan of 132 feet, an empty weight of 70,000 pounds, a maximum takeoff weight of around 180,000 pounds, and a weapons load capacity of around 20,000 pounds, with a maximum speed of at least Mach 0.8 or just under the speed of sound. The B-21's large and diverse payload of bombs and missiles is expected to include the JASSM-ER cruise missile, GBU-57 bunker-destroying bomb, and GBU-31 JDAM satellite-guided bomb. The aircraft's stealth capabilities have been significantly enhanced, making it harder for adversaries to detect. These improved capabilities include curved surfaces and the use of radar-absorbent materials to reduce its radar cross-section. The B-21 also likely employs advanced electronic emissions control systems to minimize its electronic signature, allowing it to spoof adversary radars and disguise itself as another object. It was conceived primarily as a way to breach China's supposedly impenetrable Anti-Access Area Denial or A2AD shield and to begin ground strikes to take out sensitive targets in case of a conflict. After 8 years of development and testing and tens of billions of dollars in research and development, in the simulation the B-21 is finally ready for real-world combat action. The first targets are the cornerstone of China's air defense grid, its high-tech military radar installations. By some accounts, the B-21 has a radar signature the size of a golf ball. Others say it's the size of a mosquito. Either way, even with their air defenses fully intact, the B-21 already gives the PLA nightmares trying to track it, let alone attempt to defend against it. With its vaunted radar tracking systems turned to smoldering scrap metal, China's air defenses lie in tatters. The next target is China's array of anti-air missile launchers, already significantly compromised by the destruction of their radar systems that guide the missiles. Massive explosions light up the Chinese countryside as the B-21s pummel China's TELs and other missile launch systems. But before all the anti-air defenses can be neutralized, some missiles are still launched and hurtle towards the B-21s. The B-21s detect, outmaneuver, and then destroy the incoming missiles before obliterating the remaining launchers. China's air defenses are comprehensively breached, but they're not quite done yet. Frantically, they scramble J-10 fighters into action from Huzhou in Zhejiang province. Undeterred, the B-21s shoot over Zhejiang and head for Anhui. With a range of over 14,000 kilometers, the B-21 can strike anywhere in China. They reach Anqing City in Anhui province, home of one of China's largest air force bases. Streams of GBU-31 2,000-pound guided missiles are launched from the B-21's missile bays. The base doesn't stand a chance and goes up in flames as the missiles strike. Now the Chinese authorities panic completely. Air raid alert sirens start sounding all over the country. The squadron of B-21s leaves Tianjin and streaks towards Beijing, China's vast and densely populated capital. With its radar destroyed, there's no way for China to detect the approaching bombers and take defensive action. Another barrage of GBU-31s is launched. Massive explosions rock the city as China's munitions factories are hit by the bombs. The next targets are government buildings. The sky is filled with the sight and sound of American missiles flying towards their targets and explosions as they hit them. All facilities known or suspected to be Chinese Communist Party or CCP premises are attacked. While Beijing is engulfed in flames, the B-21s leisurely fly over and survey their handiwork. The Chinese J-11 fighters dispatched to defend against the B-21s unknowingly find themselves exposed to their foe above the East China Sea. The Shenyang J-11 or Jan-11 is a Chinese multi-role fighter aircraft that is a licensed-built variant of the Russian Sukhoi Su-27 SK fighter. Its NATO codename is Flanker. It's a highly maneuverable fighter aircraft capable of conducting air superiority and ground attack missions and is armed with a 30mm GSH-31 cannon. The aircraft is capable of carrying a wide range of missiles, including the PL-12 radar-guided air-to-air missile, PL-9 short-range infrared homing air-to-air missile, PL-8 air-to-air missile, Vympel R-77 medium-range air-to-air missile, Vympel R-27 medium to long-range air-to-air missile, and Vympel R-73 short-range air-to-air missile. It also has an unguided rocket launcher and freefall cluster bombs. However, all of that capacity is to no avail, because the B-21 has the ability to engage fighters as well. They launch a battery of AIM-120 missiles, which sear through the sky towards the J-11s. The AIM-120 AMRAAM is a high-performance, all-weather, beyond visual range, air-to-air missile developed by Raytheon. Once launched, the missile guides itself to the target using inertial guidance and updates via data link from the launch aircraft. It has a maximum speed of Mach 4 and excellent endgame maneuverability, making it difficult for targets to evade. It also boasts a home-on-jam guidance mode to counter electronic jamming, along with a self-guiding terminal mode using its own monopulse radar set. With a range of 20 to 30 nautical miles and a 40-pound high-explosive blast fragmentation warhead, the AIM-120 is a highly capable and reliable air-to-air missile that packs a serious punch. The AIM-120s hunt down their opponents, and seconds later, 3 of the 4 Chinese jets burst into flames as the missiles hit them. The remaining J-11 decides that discretion is the better part of valor, turns tail, and flees for its life. Satisfied, the B-21s turn around and head back to base at the end of an extremely successful mission. A raid like this would be a massive blow to China, not just due to the extensive damage done to its military, industrial, and administrative capacity, but also to its ambitions to match the US as a global power, especially in Far Eastern Asia. Chinese military planners are wary of the B-21 providing a massive propaganda victory for the US. Even a tactically prominent victory for the B-21 will deflate China's aura of technologically rivaling the United States, demonstrating for all to see what is supposedly invincible stealth fighters, unbreakable A2AD so-called Great Wall, allegedly impenetrable integrated air defense network, and a larger navy than that of the US could not stop US bombers from striking the Chinese mainland. This would derail the narrative with which China is wooing the global south, that it has metamorphosed from a poor third-world overpopulated mess into a prosperous, advanced and powerful state, well on its way to unseating the ruling hegemon, namely the US. But just how realistic is the scenario described in the simulation, and what can China do to counter the threat? Well, firstly, the B-21 is still being tested at Edwards Air Force Base, California, and the first units are only due for delivery in 2027. This simulation is still very much hypothetical. Both the US and Chinese sides seem to agree that given the current status quo, it will take a significant number of B-21s to pose an existential threat to China. For this reason, the US intends to ultimately have a fleet of at least 150 B-21s, with both the US Air Force and China assessing the number needed to be able to get past China's defenses and cause serious damage on the Chinese mainland to be around 100. As it currently stands, most experts, whether American, Chinese, Russian, or neutral, are of the opinion that when it comes to the South China Sea and the waters and airspace over and around China, the Chinese hold a significant home advantage over the US. Former US Navy Indo-Pacific Command Chief Admiral Harry Harris and his successor Admiral Phil Davidson have both voiced their concerns before the Senate Armed Services Committee about the ability of China's ground-based missiles to threaten US aircraft carriers and bases in the Indo-Pacific region due to their superior range, speed, and sensor performance. And in a Stimson Center webinar in 2022, US Marine Corps Assistant Commandant General Eric Smith admitted that logistics to sustain a long, drawn-out conflict in East Asia is another handicap for the US. Coupled with China's vast and multifaceted anti-air defense systems, these are the main reasons why even wargames conducted by Western think tanks like the RAND Corporation and the Center for Strategic and International Studies do not result in conclusive victories for the US. The B-21 forms an important part of US initiatives to try and place itself in a more advantageous position facing off against China by introducing a series of innovative new concepts of military operations. These include the Force Design 2030 Expeditionary Advanced Base of Operations, or EBO for short, Distributed Maritime Operations known as DMO, and Ghost Fleet Overlord. The idea is for small, mobile and hard-to-detect marine littoral combat regiments placed on friendly, nearby islands to threaten Chinese shipping with long-range missiles. The US Navy's unmanned surface vessels will take the heat off its crewed vehicles, allowing them to focus on larger fleet-level operations. These plans also include the Rapid Dragon concept, which involves using workhorse cargo planes and tankers like the C-130J Hercules, MC-130 Commando II, and C-17 Globemaster III to release dozens of missiles packed in large pellets from their main doors mid-air, overwhelming Chinese radars, sensors, and kill chains. The B-21 plays an important role in this overall strategy to compromise and get through China's comprehensive, and at least for the meantime, intimidating anti-access area denial defense strategy and setup. The B-21 will be able to break through China's defenses and begin a ground strike operation to destroy critical enemy installations, command and control, and radar centers, like in the simulation. With its long-range, low observability, and nuclear capability, it's designed to be utilized on day one of a potential conflict scenario with China, greatly reducing the time it would take to respond to a crisis anywhere in the Indo-Pacific region. So what are the Chinese defenses that the B-21 would have to get past to cause the damage that it was designed to inflict? As suggested in the simulation video, there are four main components to Chinese defenses that the B-21 will have to overcome in order to successfully conduct a raid on the Chinese mainland. The first component is distance, the easiest of the four for the B-21 to overcome. The Chinese strategy of building long-distance missiles with long range beyond what the US and its allies have to offer in response, and placing these missiles on man-made islands at an increasing distance from their shores, creates quite an effective deterrent against encroaching US naval and air assets. But as mentioned earlier, the B-21's flight range of around 14,000 kilometers means that even if launched from the continental US, within a matter of hours the aircraft will be over Chinese airspace. They can be refueled in the air if needs be, and if launched from Guam or the Philippines, it would engage the enemy even faster. The second and arguably most important component is China's high-tech network radar system. Despite the B-21's minuscule radar signature, some of China's radar capacity might still be able to detect the B-21's approach, especially when the planes are refueling. In this regard, the state-of-the-art YLC-8E Chinese anti-stealth radar system, touted as the flagship of Chinese stealth radar, looks like a tricky opponent to get past undetected. The YLC-8E provides UHF-band 3D surveillance with full coherent digital pulse compression and moving target detection technology. Some sources even claim that the YLC-8E uses quantum particles for target detection, although this is just speculation at this point. Its gigantic antenna array, coupled with advanced information processing technology and AI capabilities, allows it to detect and track aircraft over 500 kilometers away and missile threats up to 700 kilometers away. With a propelled chassis providing high mobility and strong anti-jamming capability, it looks like a formidable early warning system, and it remains to be seen whether the B-21's advanced stealth characteristics will be sufficient to not only slip past the YLC-8E undetected, but destroy China's stock of these systems. The third component of China's defenses that the B-21s will have to deal with is China's vast and multi-layered missile defense system, based on the ground, at sea, and even fired from its fighters and bombers. These include the integration of Russia's formidable S-400 system. The latest missiles for the S-400 have a range of 249 miles, but they can also fire medium and short-range missiles, allowing them to engage at multiple ranges. China also has its homegrown HQ-9, roughly equivalent to Russia's S-300, which is a long-range surface-to-air missile capable of engaging a wide range of aerial targets, including aircraft, helicopters, unmanned aerial vehicles or UAVs, cruise missiles, air-to-ground missiles, guided bombs, and ballistic missiles. With a top speed of around Mach 4, a flight ceiling of around 30 miles, and a range of around 150 miles, the HQ-9 can conceivably be a big problem for the B-21, provided that Chinese radar and communication systems are intact and enough of them are fired. The last and potentially most hazardous component of Chinese air defenses the B-21 will have to vanquish in order to inflict maximum damage to the Chinese mainland is the PLA Air Force's fleet of stealth fighters, which is currently being upgraded in a major way. Plus, they have their own state-of-the-art stealth bomber, the H-20, currently in production. When it comes to their stealth fighter capabilities, it's already debatable whether the B-21 will be able to compete with China's 4th-generation J-10 and J-11 stealth fighters, or even the higher-spec Shenyang J-15, as nonchalantly as in the simulation video. So it's likely that they'll have an even tougher time up against the 5th-generation J-20, nicknamed the Mighty Dragon, and brand-new stealth combat aircraft, the J-31B. Defense journal Janes has reported that in the 11 months leading up to July 2023, the PLA Air Force incorporated over 70 new J-20s, bringing the total to approximately 195 aircraft as of May 2024. These are spread across 12 air brigades, with 3 fully outfitted with the J-20. The J-31B looks to be a substantial upgrade on China's current workhorse, the J-15, and can be seen more or less as an equivalent to the US's F-35. It can carry an assortment of munitions such as the PL-10 and PL-15 air-to-air missiles, various guided bombs, and air-to-ground missiles, and has weapons bays on both sides which can carry 2 missiles each, increasing its capabilities in close-range fighting. It also features AESA, or Active Electronically Scanned Array radar, an electro-optical targeting system, and a helmet-mounted display system. Then there's China's first attempt at a 5th or 6th generation stealth bomber, the Xi'an H-20. Currently, very little is known about this aircraft, which was first announced back in 2016, but has been shrouded in secrecy ever since. In March 2024, Newsweek cited a Chinese official as saying the H-20 would be ready soon, as there were no longer any major challenges left for the development. It's believed to be a modification of the American B-2 Spirit bomber, which of course is being replaced in the US Air Force by the B-21. In a paper published in the peer-reviewed journal Acta Aeronautica et Astronautica Sinica in October 2023, a Chinese research team found in a simulated wargame that the H-20 would come out on top in a duel between the B-21 and H-20, thanks to the unpredictable trajectory of the H-20's missiles. However, the US Department of Defense, at least officially, has utterly dismissed the threat posed by the H-20. A Defense Department intelligence official speaking to reporters on the condition of anonymity was reported by Defense One as saying, "The thing with the H-20 is when you actually look at the system design, it's probably nowhere near as good as US low observable platforms, particularly more advanced ones that we have coming down. They've run into a lot of engineering design challenges in terms of how do you actually make that system capability function in a similar way to a B-2 or B-21. The same official also cast doubt on Chinese claims that their bomber is coming soon, saying it could still be many years away, and that even if the bomber is unveiled, it doesn't mean that it would have the kind of capability that they would need, or the quantity that they would need. This is the same argument one might expect the Chinese military brass to be making about the B-21, and to some extent that's exactly what the initial response to the B-21 has been. That said, reading between the lines, they're definitely worried. The scramble to implement new radar, new missiles, new stealth fighters, and even a 6th-generation stealth bomber of their own indicates their concern is very real and very urgent. In a 2023 case study for CASI, Derek Solon, a senior researcher for Air University's China Aerospace Studies Institute, analyzed media reactions within China to the B-21's unveiling in November 2022. One of the more dismissive analyses appeared in the Liberation Army News, which he described as the mouthpiece of the Chinese Communist Party's Central Military Commission. The writers argued that the B-21 may be strategic blackmail, intended to force the kind of expensive and disruptive countermeasures that the Chinese have in fact been forced to take. They also predicted that the B-21 program would not achieve economies of scale due to its astonishing total cost, and therefore it would be difficult to achieve any strategic effect. Other Chinese media outlets also cast doubt on the B-21's affordability and its ability to infiltrate China or Russia's robust high-tech radar and missile defenses. However, not all of them are taking the threat so lightly. Xin Qizi, writing for Chinese National Defense News, wrote that the B-21's main advantage over the B-2 is that the Air Force can afford more of them, and urged readers not to treat the threat lightly. Overall, the US Air Force's assessment that China hopes the US can't afford enough B-21s to make a difference would appear to be correct. Both the US and China seem to have come to the conclusion that it would take a fleet of at least 100 B-21s to pose a considerable threat to China. Officially, the US intends to assemble a fleet of 150 to 200 B-21s by the early 2030s, completely replacing the B-1 and B-2 Spirit stealth bombers currently in service. But how realistic is that? Although the cost of the B-21 prototypes currently being tested has reportedly come in below budget at around $700 million each, some American air power policy experts argue that the Air Force needs to greatly increase its proposed production rate of B-21s to provide their long-range power projection necessary to deter China. Meeting both time and budget deadlines may require doubling the bomber's production rates and reducing unit costs. This would require difficult force structure trades if the Air Force budget remains static, wrote Dr. Christopher J. Bowie, non-resident senior fellow at the Center for Strategic and Budgetary Assessments, in a report published March 10, 2023. And that may be easier said than done. A recent article about the promise of the B-21 in the national interest pointed out that an expected cost of $700 million per plane, for a total cost of over $4 billion, the Air Force has already had to scale down what it wants from 300 planes to around 150. The US military is stretched to its breaking point, despite consuming vast amounts of financial resources that the United States can no longer afford to bear. Even with all the money pouring into the elephantine defense establishment, the US defense industrial base is a sclerotic, inefficient mess, according to the article. That is in all likelihood overstating the case somewhat, especially considering that the US is already responsible for a full third of the world's aggregate defense spend, more than all its main rivals combined. However, given recent issues with testing of hypersonic missiles and other R&D setbacks and budget blowouts, it remains to be seen whether the US can bring to fruition the promise of the B-21 by producing enough of them in good time to pose the desired threat. Time will tell. But what do you think? Is the B-21 something the Chinese should be panicking about, or is it going to be a costly white elephant? In a move that sent shockwaves through military circles and beyond, the United States Air Force dropped a bombshell in May 2021. The F-22 Raptor, hailed as the zenith of jet fighter technology, was earmarked for an early retirement. Despite its unparalleled dominance in the skies, plans were set to phase out the Raptor by 2030, with an immediate proposal to retire 33 of these aerial titans. This decision, met with disbelief and a stern rebuke from Congress, begs a burning question. Why sideline the world's supreme fighter jet, a marvel that's yet to reach the midpoint of its operational life, especially when its predecessors, the F-15 and F-16, boast half a century of service?
Unraveling this puzzle takes us on a journey through the tumultuous saga of the F-22's development and into the horizon of what lies beyond in the realm of aerial combat. What led to this dramatic turn? What comes next that's so advanced it makes retiring the F-22 seem like a good idea? Let's find out. The journey of the F-22 began in 1981 with the ambitious sketches of the Advanced Tactical Fighter Program. At the time, the F-15 Eagle was the pinnacle of American air superiority, outclassing anything the Soviet Union had in the skies. Yet the US Air Force was already envisioning its successor, a fighter jet that would not only maintain but extend American dominance in the air. This was no small feat, considering the Soviet Union and its allies outnumbered the US in terms of aircraft. The vision was clear: create a fighter jet that was stealthier, more agile, and faster than the F-15, one that could soar at supersonic speeds without the gas-guzzling afterburners. This new warrior of the skies would need to execute precision takeoffs and landings from shorter runways, boasting avionics so advanced they could blind the enemy's eyes and ears. The goal was to craft a jet capable of penetrating enemy defenses with the stealth of a shadow, striking critical targets and enemy fighters before they knew what hit them. It was a strategy inspired by Israel's stunning success in Operation Focus during the Six-Day War, where their air campaign's decisive victory showcased the strategic value of air superiority. In the event of a direct confrontation, this next-generation fighter would prove its worth in gold, outmatching multiple enemy planes in a dance of death. With grand plans to acquire 750 of these Titans for an estimated $64.3 billion in 1981 dollars, a figure that skyrockets to nearly $220 billion today, the Air Force set the stage for a new era. The competition was fierce, but Lockheed Martin's YF-22 design triumphed over the formidable YF-23, a collaboration between McDonnell Douglas and Northrop Grumman. However, the combination of international developments and program difficulties conspired to thwart the Air Force's original plan. The Soviet Union collapsed in 1991, and with the end of the Cold War and the start of America's period of undisputed international hegemony, there was much less of a need to spend so much money on a next-generation fighter. In 1999, the Air Force's proposed purchase order had dropped to 341, with a cost just shy of $200 million per plane by the time the Raptor deliveries ended in 2012. The final number was set at 187 production aircraft plus 9 test planes. Of these, only 150 are considered fit for combat. This number was adequate for the time, with America's international dominance still near its height and the only threats on the horizon being the low-level ones seen in the War on Terror. Even so, as the Raptor's production was being cut, there were voices warning of China's growing military might and the possibility of a resurgent Russia. They urged the Air Force to reverse course and acquire more F-22s. This was not to be, and there were too few Raptors on hand to replace the F-15 and F-16 fighters in the USAF fleet as the service had originally intended. Unfortunately, the voices warning in the 1990s and 2000s of a resurgent Russia and more aggressive China have proven to be right, and now the United States lacks the aerial dominance that the bigger Raptor fleet would have given it. To make up for the lack of numbers, the Air Force operates the Rapid Raptor program, which readies the F-22 to be surged to strategic hotspots that might require its presence. Under this program, at least 4 Raptors will be ready to go in response to emergencies anywhere in the world, with the appropriate crew, transport craft, fuel, and weapons needed to support them. Tellingly, the Air Force's Pacific Command was the original creator of the Rapid Raptor program, but it's since been expanded worldwide. As well planned as the Rapid Raptor program is, it still reveals the lack of F-22s available in the event of a full confrontation. 4 additional F-22s, as good as they are, would likely not be decisive in tipping the balance of a full-scale invasion of Taiwan, for example. To add to the problem of limited numbers, the F-22 is also a very expensive aircraft to operate, with a cost of over $85,000 per flight hour. This high cost is related to the need to maintain Raptor's stealth qualities and its F-119 engines. In contrast, the F-35's cost per flight hour is slightly less than half of the Raptor's, at about $42,000. Meanwhile, the F-16 costs about $27,000 per flight hour. To make matters worse for the Raptor's economics, the United States Congress banned all sales of the F-22 to foreign countries in 1997 in a bid to protect its technological edge. To this day, the United States is secretive about the plane and takes extra precautions when it operates even with its closest allies. The potential for export is one of the most important ways to pay for a weapons program. It's one of the reasons why the F-35 is much more economical than the F-22, despite also suffering for years in developmental hell and having high acquisition and flight hour costs. Because of international sales, F-35 prices have dropped over time, from $89 million per unit in Lot 11 to about $78 million in Lot 14, although they have since risen again. In contrast, the United States shouldered the entire burden of developing and manufacturing the F-22, and the order was for so few aircraft that costs remained high and there was a lack of spare parts. The F-22 is also not without its problems. Since it began its life in the early 1980s, it's beginning to show signs of being middle-aged. The F-22's timing was off in another way. In the 1990s, the US military began to understand that the pace of technological development would accelerate. New weapons designs therefore needed to be based on open architecture to allow for rapid upgrades of software and components rather than creating an entirely new platform to accommodate the change in technology. The F-22 was not designed for such adaptability, and by the time the Air Force came to realize this increasing pace of technological development, the program was too late in its development to change. While the Raptor has gotten and is getting its fair share of upgrades, they are much more difficult and expensive in contrast to the F-35, thanks to the latter's open architecture design. Another of the biggest challenges for the F-22 is in sharing its data. Its computer systems cannot communicate directly with the F-35, for example. To do so, the Raptor often needs to translate its older programming language through U-2 surveillance aircraft. This arrangement is obviously less than optimal. The F-22 also needs better resistance to modern electronic warfare and better sensors to more reliably detect lower observable aircraft like China's J-20. The F-22's engines are also an issue. Although they are remarkable powerhouses capable of generating 35,000 pounds of thrust for a combined total of 70,000 pounds, this power limits the Raptor's range. The F-22 can fly for distances of about 1,850 miles, but this is only in its ferry range with the addition of 2 external fuel tanks beneath its wings. These external tanks, however, make the Raptor much more visible to radar, and even when they are dropped, the pylons they were attached to still have a negative effect on its stealth profile. With all of this in mind, the Raptor's effective combat range is much more limited. By comparison, the F-15 Eagle has a range of 3,450 miles with its fuel tanks. The Raptor's range could be sacrificed in a war over the crowded continent of Europe, but the Raptor is less than ideal in a confrontation over the much greater distances in the Indo-Pacific region, where an aggressive China occupies the first place in Washington's foreign policy priorities. The F-22 is being upgraded to cover for many of these disadvantages, but the upgrades are expensive and difficult. We will have more on the specifics of these upgrades before the end of the video. The final nail in the coffin for the Raptor's viability is that it's almost impossible to manufacture any more of them. With a limited fleet and no foreign sales, the infrastructure and human capital needed to build the plane was allowed to atrophy. The tools and expertise that could be reused were shifted to the F-35 program. For example, the Raptor's radar-absorbent coating is different from the F-35's. Making more of it, with the necessary modern upgrades, would be prohibitively expensive. All told, restarting Raptor production would take years and tens of millions of dollars invested. Newly built F-22s would cost between $206 and $216 million each, on top of the millions it would take to recreate the necessary manufacturing capacity. With these factors in mind, perhaps it should not be surprising that the Air Force began to look ahead of the F-22. It simply made more sense to build a new aircraft, one that would be more economical, better designed, and more adaptable to handle present and future challenges. Enter the Next Generation Air Dominance (NGAD) program. The NGAD will be America's first 6th-generation jet fighter. As the F-22 set the benchmark for the 5th generation, its successor will be doing the same for the 6th. 6th-generation aircraft will, above all, be smart planes, fully integrated into the information warfare network with the assistance of artificial intelligence to help pilots prioritize the increasing amounts of information presented to them. These fighters would also have adaptive engines to make more efficient use of fuel, which would give them longer range without refueling. They would also carry higher payloads than 5th-generation fighters, while maintaining their stealth profiles, fly with drone wingmen, and can also be operated as drones themselves. Like the F-35, the NGAD will be designed around open architecture, meaning that it will avoid the modernization problems that make maintaining the F-22 so expensive. Although the cost per plane is likely to be $300 million apiece, the Air Force plans on purchasing at least 200 to 250 of them and 1,000 of its associated drones. There may be additional tranches following the initial purchases. Although this price tag sounds crippling, buying the NGAD in bulk will drive down the aircraft's manufacturing costs and ensure an availability of spare parts to better maintain the fleet. These factors will make the NGAD less expensive to operate than the F-22 in the long run. One prototype NGAD design had its maiden flight in 2020. Lockheed Martin and Boeing are the two main competitors, with the winner to be announced later this year. At that time, we may get to see the design of the aircraft. The speculation is that the NGAD will look a little like the B-2 and B-21 bombers, lacking any vertical structures like the F-22 and F-35's tail fins. Although designers have worked around these structures, they produce a significant radar return by their nature. The lack of these structures suggests the NGAD will be going all in on long range and low visibility. In contrast, the F-22 was essentially designed to be a stealth dogfighter. The NGAD's design is going to be a very big problem for Russia and China. These two countries, China especially, rely on anti-access area denial strategies to make up for the disadvantage they would still be in during a full confrontation with the US military. Sophisticated air defense networks and missiles that can defeat America's stealth fighters are a priority for Moscow and Beijing. There's no indication that these systems, like Russia's S-400, can reliably shoot down stealth fighters yet, but there is no doubt that in the future, the biggest threat to the F-22 will likely not come from enemy aircraft, but from surface-to-air missiles. The NGAD will be designed to defeat such a threat, and in this regard, it's part of the Pentagon's third offset strategy, which was envisioned in 2015 to counter peer or near-peer adversaries using A2AD strategies. In contrast to the NGAD, designed to counter the modern threat environment, the war the F-22 was designed for never came. Tellingly, its first air-to-air kill came in the Chinese spy balloon incident of early 2023, when a Raptor shot the offending target down near the coast of South Carolina. The NGAD's purported design suggests that it won't be as maneuverable as the F-22, but for a modern air battle, maneuverability is increasingly irrelevant. Most targets will be shot at from beyond visual range. Stealth, informational superiority, and the ability to strike at long range will increasingly be the most important part of air warfare. The Air Force is incorporating this idea into the heart of the NGAD, and although this conclusion once proved disastrous over the skies of Vietnam, it's more arguable that the idea back then was too far ahead of its time. Now, with much more sophisticated radar and longer-range, smarter missiles, the time has come. With these threats and technological realities in mind, the Air Force has concluded that in the long term, keeping a very costly platform like the F-22 Raptor around, one not as well adapted for a changing environment and which cannot be rapidly upgraded, is not in America's best interests. It would rather be a less than optimal investment compared to resources that could better be spent elsewhere. In this regard, Russia and China would likely be happier to see America continue to spend mountains of dollars on the F-22 rather than going all in on the NGAD. In its budget request for 2024, the Air Force proposed retiring its first Raptors. These are the 32 Block 20 F-22s that are considered non-combat coded. Instead, these aircraft have been used for training. The Air Force does not want to modernize these planes because it claims doing so would be too expensive. It instead argues that those resources will be put to better use on the NGAD. Congress has denied this request and has protected the Block 20 Raptors through at least fiscal year 2026. Possibly in response to such protections, the Air Force claims that the newer, combat-capable Raptors will remain its highest priority in the short term, and it will continue to upgrade them accordingly. Such upgrades include the use of the new AIM-260 JATM, which will replace the AIM-120 AMRAAM as the Air Force's air-to-air missile of choice before the end of the decade. Although its exact details are classified, the JATM was designed to counter the range advantage China's PL-15 missile has against the AMRAAM. This would put the JATM's range in excess of 120 miles. Other upgrades likely include longer ranges and better sensors. Official Air Force renderings and recent photographs showed the upgraded F-22s featuring new external fuel tanks that would not compromise the plane's stealth profile. The new tanks are the product of the Low-Drag Tank and Pylon program. While these external fuel tanks are stealthy, unlike their predecessors, they also have a design advantage in that when they are dropped, they drop the pylon with them, keeping the Raptor's stealth profile fully intact if it needs to enter combat. These fuel tanks will likely prove useful for the F-35 and the NGAD as well. The official renderings also show external sensor pods to improve the Raptor's situational awareness through infrared search and track targeting (IRST). This feature permits the pilot of a fighter aircraft to target the heat signature of an enemy aircraft independent of radar targeting. The F-22 ended its production run too quickly to add this feature, but it's present in the F-35 and, more importantly, China's J-20 and Russia's Su-57. These systems are one way to detect the presence of stealth aircraft. Good engineering can mean less radar visibility, but every aircraft will emit a significant amount of infrared radiation, and the range of these IRST systems is increasing. The F-22 finally getting an IRST was necessary to ensure it remains the undisputed master of the air. Reportedly, the aircraft can travel at Mach 1.2 with both of these external attachments. The F-22's latest slew of upgrades will also make it more resilient against modern electronic warfare like spoofing and jamming. The Raptor's situational awareness will also improve because electro-optical targeting systems will feed data into the pilot's helmet. Surprisingly, F-22 pilots have had to navigate the dashboard and turn their planes toward their targets to get a shot. This archaic feature shows the age of the Raptor program overall, but soon Raptor pilots will be able to target enemy aircraft just by looking at them, much like their comrades flying in the F-35. These upgrades will be welcome because even if the NGAD is operational by 2030, it will take some time for the new fighter to be manufactured in sufficient numbers. With Russia gaining momentum in Ukraine and China making overtures of having the capability to successfully invade Taiwan by 2027, the Air Force cannot yet afford to give up the superiority capability that the F-22 brings to the table. But these upgrades, while ensuring the F-22 will remain the most dominant fighter in the world until the NGAD arrives, also betray the reasons why the Air Force is so set on retiring the Raptor fleet early. The upgrades will cost at least $9 billion through 2030, and that number came on the assumption that the Block 20 F-22s would be retired, which so far they have not been. By that math, upgrading each individual plane would cost something in the neighborhood of the price of a new F-35. Given the Raptor's other drawbacks, this is simply not viable as a long-term investment. The F-22 Raptor remains the world's best fighter jet, for now. Its ability to combine stealth and long-range hit-to-kill ability with traditional dogfighting attributes like speed and maneuverability is unparalleled, and might even exceed the NGAD. However, modern contested airspace increasingly has no need for such capability. With this reality and the F-22's prohibitive costs, it should not be surprising that the Air Force does not have long-term plans for it. By the middle of the century, the Air Force plans to field only 4 aircraft in its fighter fleet, down from the current 7. These 4 will be the NGAD, the F-35A, the F-15EX, and the latest version of the F-16. There is no room for the F-22 in these plans once the NGAD is ready. That's a good thing. What do you think about the Air Force's plans to begin retiring the Raptor? Is the brass making a mistake, and will Congress further intervene to save the F-22? China has plans to become the world's leading superpower by 2049, but a new missile for America's carrier jets is about to turn Xi Jinping's China dream into a nightmare. How close is China to a catastrophic downfall? Could this new missile be the key to unraveling Beijing's ambitions and bringing an end to its rise? What does this weapon mean for the fragile balance of power in the Indo-Pacific, and is China on the brink of losing it all? Prepare to uncover the story behind this ingenious innovation that could alter the course of global power. China has certainly made strides in its military capabilities over the last 2 decades, transitioning from what was once considered a military backwater with outdated equipment and a poor performance record, particularly after its experience in the Sino-Vietnamese War of 1979. But is it enough to fully match the power and technological sophistication of the United States? Hardly. The US is increasingly adept at disrupting these, ensuring its carriers and other assets remain a potent force in the region. China's geographical proximity to potential conflict zones may seem advantageous, but these also make its forces vulnerable to rapid US counterstrikes. While any military confrontation would undoubtedly be challenging and costly, the United States' superior technology, strategic alliances, and innovative capabilities, such as the development of the new AIM-174B missile, ensure it remains well-positioned to counter any Chinese aggression. And this is just the beginning. The US has another big advantage against China's missile threat, its fleet of nuclear submarines. China, in a bold attempt to challenge this, is developing its own undersea predators, but the question remains, can they truly rival America's might? China's new submarine models, the Type 095 and 096, are set to emerge in the early 2030s, designed to be quieter and more elusive, potentially shaking US dominance beneath the waves. Yet despite these efforts, the United States remains not just a step, but a league ahead. With a battle-hardened submarine fleet that has no equal, the US Navy continues to dominate the depths with unmatched stealth and deadly precision, ready to neutralize any threat and maintain its iron grip on undersea warfare. China's efforts to lead the hypersonic missile race, including the development of the PL-17 missile, represent another attempt to challenge US air superiority. The PL-17 is an air-launched missile carried by fighter jets. China claims that the munition has a dual-pulse solid rocket motor that combines with a lofted trajectory, and that these features could ensure it hits targets 250 miles away. However, these new Chinese weapons have a weakness. They rely on a series of steps to find and engage their targets. The Pentagon calls this sequence a weapon's kill chain. The kill chain for a basic weapon like a 155mm artillery shell is fairly simple. A simple, dumb artillery shell need only be set to its desired location by a gunner and then shot. Unless the shell is stopped from being sent forward by counter-battery fire, there isn't much that can disrupt it. Even if the shell winds up being a dud on impact, it might still explode later if set off, essentially becoming an unintended landmine. This is a weapon with a short kill chain. But dumb shells are inaccurate, and ammunition depletion has meant that Russian gunners have been forced to change their tactics in Ukraine. In 2023, Russian artillery units started to trend away from their previous World War II-style saturation fire approach. Instead, they began to prefer Krasnopol laser-guided artillery rounds. The tactics have worked, but there is a weakness. These rounds require laser designators to accurately hit their target, which means they have a more complicated kill chain than their dumb counterparts. Take out the laser designators and the Krasnopol shell reverts to a much more expensive dumb round. A long-range guided missile like the PL-17 has a still more complicated and expensive kill chain. The PL-17 most likely has an active and passive radar guidance system. Passive sensors will be used to detect radar emissions from enemy aircraft, especially AWACS aircraft. The passive sensor is likely combined with target location updates from off-board sensors coming from friendly AWACS aircrafts, ships, or command and control stations during most of the missile's flight path. This guidance ensures the missile keeps flying in the proper direction. It also prevents the target from detecting its presence. Finally, the PL-17 has an active seeker for the final phase of the attack path to hone in on and destroy the target. But if one thing in that sequence goes wrong, the system is knocked out of alignment. If the passive sensor fails, the missile will not be able to find a target. If the active seeker fails, it cannot lock on for the final flight path. If the off-board sensors go down, the missile becomes less accurate and more detectable. Designated targets can take countermeasures from there. The PL-17 is a stark reminder that today's smart weapons are only as strong as the intricate kill chains they depend on, a reality the United States has not only recognized but mastered. But the United States is also hyped on getting involved in the kill chain disruption game, and recent sightings of FA-18 Super Hornets have revealed them carrying a peculiar weapon. During the 2024 Rim of Pacific RIMPAC exercise, Hawaii-based Super Hornets from the Strike Fighter Squadron 192, based aboard the USS Carl Vinson, were spotted sporting an unusual pair of missiles. Photos revealed that they had blue bands painted on them, indicating that they were not armed with an explosive warhead or live motor. It was their shape that made them so distinguishable. They appeared like aircraft-delivered versions of the SM-6 missile. Raytheon manufactures this missile. It entered service on the US Navy's cruisers and destroyers in 2013 and is designed to be a multi-domain projectile capable of anti-air, anti-ship, and missile defense missions. It has a range of 230 miles and a speed of about Mach 3. The Pentagon has also admitted that the SM-6 has a counter-hypersonic capability. The SM-6 has a solid rocket booster and dual-thrust rocket. It combines these with the nose cone and seeker of the AIM-120 AMRAAM. The AIM-120 seeker gives the SM-6 numerous advantages. The AMRAAM operates in the X-band of radar, which means it has higher resolution than shipboard spy radars. However, because the SM-6 has a larger airframe than the AMRAAM, it can host a larger seeker. The SM-6's active terminal seeker also provides a number of advantages. Most importantly, it can engage targets beyond the range of its host ship's radars. Since these are limited by the ship's power output and the Earth's curvature, the SM-6 gives the US Navy's ships longer reach. The SM-6 is networked with other systems. Other platforms like the Aegis-equipped ships or AWACS aircraft can provide it with remote targeting that's not part of the missile's original launch platform or its onboard sensors. This attribute makes the missile part of the US Navy's Naval Integrated Fire Control Counter-Air Network. For example, a ship can launch the SM-6, an AWACS or F-35 can then guide the missile to a high-value target. These attributes mean the missile is not limited to the sensors of its launch platform or its onboard seekers. The only limitation is its own mechanical qualities. Now, the Navy has adapted the SM-6 for an air-launched role. The new variant is called the AIM-174B. The Navy said in an email to Flight Global that this missile is already operationally deployed. In other words, it's ready for combat. And just like that, the United States now has the world's confirmed longest-range air-launched missile. Its range is 3 times longer than the AMRAAM, longer than China's PL-15, and at least comparable to the PL-17. The AIM-174B's advantage extends beyond its long range. The war in Ukraine has shown how much ammunition matters in a conflict and how fast it can be depleted in high-intensity combat. Getting production lines ready for the AIM-260 is one of the reasons why the new missile will not be deployed in large numbers for the next few years. In contrast, the SM-6 has been in service for over a decade. There is already industrial capacity in place to build and distribute it. The brass at the Pentagon may have gotten the idea to adapt this weapon for airborne launch by watching the Ukrainians, who have made a habit of combining weapon systems and delivery platforms in ways no one expected. For example, shoulder-fired Stinger missiles made some waves early in the war when Ukrainian operators used them to shoot down Russian helicopters. Videos of these occurrences spread quickly on social media. However, Ukrainian troops have since adapted the Stinger to a missile defense role. They've used it to shoot down some of the Russian Kh-101 cruise missiles, which have done so much damage to their cities. The Kh-101 is a subsonic cruise missile designed to fly low in an attempt to evade traditional enemy air defenses. However, these attributes made it a conceivable target for the Stinger. Although it had never been used in the role before, Ukrainian operators proved it was possible. Maybe even more unusually, Ukrainian operators have integrated American Sea Sparrow missiles, designed to protect ships, with their Soviet-era Buk air defense systems. These two systems should have been incompatible, yet the Ukrainians have used them in conjunction to defend against Russian airstrikes. The new combination has gotten the nickname Frankensam. The Ukrainians have proven that seemingly inoperable systems can be used together. With this knowledge, the United States may have been eager to try the same thing as the stakes in the Indo-Pacific region got higher. The air-launched version of the SM-6 would fall into an emerging category of weapon, the quasi-ballistic missile. Traditional ballistic missiles are launched on a high arc and then descend at a steep angle. These arcs give the biggest ones intercontinental ranges. Quasi-ballistic missiles, on the other hand, have shorter range but are more unpredictable and harder for existing missile defense systems to counter. They follow a ballistic trajectory at launch but can change their paths in flight. This makes them ideal weapons for going after high-value targets in tactical situations. The SM-6 and its newer siblings are not as capable in an anti-ship role as the Harpoon because its warhead is a lot smaller, 64 kilograms to the Harpoon's 200. However, the Center for Strategic and International Studies notes that its range makes it ideal for a mission-kill capability. Hardened ships might be able to withstand a hit from a 64-kilogram warhead, but a precise strike can destroy critical systems and make the ship inoperable for the duration of a mission. The target might still be afloat, but it will be useless in battle if these critical functions are disabled. The high-resolution seeker in the SM-6 and its new derivatives makes it valuable in potentially destroying or disabling PLAN vessels from long range and their kill chain contributions with them. Perhaps more importantly, the United States now has the same option to destroy China's AWACS aircraft. The AIM-174B also potentially gives the United States the ability to hit vital targets in Chinese territory, such as command and control stations. Here's how that would work. An F-35 can take off from a base in Japan or the Philippines. The F-35's stealth qualities ensure that it can fly closer to Chinese territory than other platforms. At the same time, an FA-18 Super Hornet armed with the AIM-174B takes off from a carrier parked outside of the first island chain, where it's safer from the Chinese missile threat. The Super Hornet then gets as close to Chinese territory as it safely can and launches the missile. The F-35 then takes over and uses its radar to guide the missile to critical targets that control a number of systems, like the large arsenal of missiles that sit at the center of China's A2AD strategy. The missile hits and the systems go down, making it safer for other assets to conduct operations deeper in the A2AD zone. China might still have most of its missiles, but it has less ability to use them. Disrupting an enemy's kill chain ensures that many of the expensive weapon systems that rely on it are useless. The AIM-174B's development is not surprising. In the mid-2010s, the United States developed a counter-A2AD approach called the Third Offset Strategy, which found its way into the 2018 National Defense Strategy. The 2018 NDS was influential in shaping future, great power competition-based security policy in Washington. The central premise of the Third Offset Strategy is to ensure that the United States can blunt the impact of A2AD technologies and continue to project power into the zone these technologies are supposed to cover. For example, the seas and skies of the first island chain would be the area where a conflict would take place between the United States and China. This means the US would need to fight thousands of miles away from its homeland, while China has the benefit of being close to its territory under the protective umbrella provided by its missile stockpile. However, if the United States disrupts the kill chain those missiles rely on, it will prevent its casualties from ballooning too much while making reinforcement and resupply easier. The United States military would therefore confidently move inside the A2AD area, while China's power becomes more contained. The AIM-174B's range and versatility makes it an important tool for the United States to carry out this strategy. So far, the missile has only been spotted on the FA-18 Super Hornet. It's not known if other aircraft, like the F-35, will be capable of carrying it. Since it was designed for use on a ship, it might be too large, at a length of 6.55 meters, to fit into the Lightning II's internal weapons bay. This is about twice the length of the AMRAAM, for example. The F-35 might not be able to carry this weapon internally, which would compromise its stealth profile. However, it does seem likely that land-based fighters like the F-15EX, the so-called missile truck, and F-16 will carry it soon too. The AIM-174B's arrival also now leaves the possibility open that the United States' coming 6th-generation fighters, the NGAD and the FA-XX, will be designed to carry the AIM-174B and others like it while maintaining their stealth profiles, enabling an even more powerful anti-kill chain platform. Despite its progress in the last 25 years, China still cannot engage the United States military in a head-to-head confrontation. To increase its influence in the region, China relies on its geographical advantage and technologies that would fortify that advantage. However, every technology has constituent parts that need to function in order for it to fulfill its mission. The AIM-174B represents a significant step forward for the United States in disrupting the kill chain China needs to effectively maintain its A2AD zone. The war in Ukraine again provides a preview of what the United States may be aiming for with the AIM-174B and weapons like it. After unilaterally annexing it in 2014, Russia heavily fortified Crimea with air defense systems, radars, and routine patrols from AWACS aircraft and ships from the Russian Navy. Aside from the Korean DMZ, it was arguably the most heavily fortified area in the world. However, Ukraine has targeted these kill chain constituents with strikes from missiles, drones, and special operations teams, notably destroying 2 of Russia's A-50 AWACS aircraft and heavily damaging a third in the early part of the year. The result is that Russia's grip on Crimea has steadily loosened, and Ukraine has conducted more and more daring operations on the peninsula, which is the linchpin of Russia's invasion. The United States has been studying Ukraine's operations and hopes that the AIM-174B will be able to do something similar in the event that conflict broke out in the Indo-Pacific. With each successful use and destruction of a high-value kill chain asset, its forces can move more boldly into China's weakening A2AD zone. Countering an invasion of Taiwan, for example, would be costly under current conditions. Destroying China's AWACS aircraft, command centers, and surface vessels would reduce its effective firepower and allow the United States to more confidently use its air and sea power in combined operations to throw the invasion back across the strait. Toward the end of the 20th century, war planners hoped to save ammunition by developing more accurate weapons, effective at longer ranges. They succeeded in their goal, but opened a new vulnerability by introducing complicated supply chains and kill chains into the equation. In future conflicts, the most important race may not be who can strike accurately first, but who can prevent the enemy from doing so by disrupting the kill chain. The advent of the AIM-174B shows that this is a race the United States is determined not to fall behind in. With innovation, it's found new uses in older weapons. What do you think about the AIM-174B? How will it affect the balance of power in the Indo-Pacific region?